साधुवाद देता हूं और साथ ही आभार व्यक्त करता हूं कि मुझे इस अवसर पर आप लोगों ने अपने विचार प्रकट करने का अवसर दिया। मैंने अपने मेरा एक छोटा सा टॉक है, इसका शीर्षक रखा था चेंज द क्लाइमेट विद इन, इट विल चेंज आउटसाइड। लगभग 2500-2600 वर्ष पूर्व भारत का एक महान वैज्ञानिक, जिसे हम सिद्धार्थ गौतम के नाम से जानते हैं, सत्य की खोज में अपना घरबार छोड़ता है और सांस से अपना कार्य शुरू करता है। लगभग 29 वर्ष की आयु में अपना घरबार छोड़ता है, अनेक गुरुओं के पास जाता है और उसके बाद जब देखता है कि अभी भी मुझे जो सत्य चाहिए, जो ज्ञान चाहिए, उसकी खोज नहीं कर पाया हूं, वो नहीं मिल पाया है, तो अपने बल के ऊपर, अपने स्वयं की प्रेरणा से बैठता है और सांस से कार्य शुरू करता है। सांस को जानते जानते, सांस की सूक्ष्मतम सच्चाइयों को जानते जानते, इस शरीर को यहां से शुरू करते करते पूरे शरीर में अंदर बाहर इसका संश्लेषण करते हुए, विघटन करते हुए, वो इस शरीर की अंतिम सच्चाई पर पहुंच जाता है, जिसको अब देखता है कि अब उस सच्चाई के टुकड़े नहीं हो सकते। उसको वो कलाप नाम देता है, आज की भाषा में बोले तो एटम, कलाप नाम देता है। और क्योंकि अब इसके टुकड़े नहीं हो सकते और इसके 4 कॉन्स्टिट्यूएंट हैं और 4 उनके गुण स्वभाव हैं, तो 8 चीजें एक साथ जुड़ी हैं, अब इनको हम अलग नहीं कर सकते, इसलिए इसको अष्टकलाप नाम दिया। 4 चीजें क्या है? पृथ्वी धातु, वायु, जैसा हम पढ़ते ही है, पृथ्वी धातु, वायु धातु, अग्नि धातु, जल धातु। पृथ्वी धातु का अपना स्वभाव, गुण स्वभाव, भारी होना, हल्का होना, ये पृथ्वी धातु का स्वभाव है। वायु धातु प्रकंपन, प्रकंपन, ये वायु धातु का स्वभाव है। अग्नि धातु शीतल होना, गर्म होना, ये अग्नि धातु का स्वभाव है। और जल धातु ये बांधने का काम करती है, ये बांधती है। तो ये 4 ये कॉन्स्टिट्यूएंट और 4 इनके गुण स्वभाव, ये अब अलग नहीं हो सकते हैं, इसलिए इसका नाम क्लाप रखा। क्लाप यानी इकाई, जैसे एटम। और फिर देखता है कि ये सूक्ष्म सच्चाई, इस शरीर की जो सूक्ष्म सच्चाई है, इकाई है, ये भी कितनी शीघ्र गति से पैदा हो रही है, समाप्त हो रही है। तो अपने अनुभव से देखता है, अपने एक्सपीरियंस से देखता है कि ये जितनी देर में मैं अपनी पलक झपकाऊं, ये अनेक शत सहस्र कोटि बार पैदा हो रही है, समाप्त हो रही है। अनेक शत क्या कह गए, अनेक शत सहस्र, शत, 100, सहस्र, हजार, कोटि, करोड़, 100,000 करोड़, 10⁻12 ये एक फिगर बनती है, और वो भी अनेक बार। इतनी बार ये स्मॉलेस्ट पार्टिकल, ये क्लाप, ये एटम पैदा होता है, समाप्त होता है। और इतनी शक्ति, ऐसे व्यक्ति के अंदर इतनी शक्ति आ जाती है कि वो अपने भीतर नहीं, बाहर भी, ये जो मटेरियलिस्टिक जो हमारा वर्ल्ड है, ये पेड़ हैं, ये पत्थर हैं, पहाड़ हैं, इनके अंदर भी ये देख लेता है कि ये स्मॉलेस्ट जो सच्चाई है, ये यही है। स्मॉलेस्ट कॉन्स्टिट्यूएंट है जो बॉडी का है, वो बाहर भी यही है, और उसी गति से ये पैदा हो रहा है और समाप्त हो रहा है। तो फिर बोलता है सभ्य लोको सभ्य लोको पकपितो पकपितो, कि सारा लोक की प्रज्वलन ही प्रज्वलन है, प्रकंपन ही प्रकंपन है, और कुछ नहीं है। तो ये इस सच्चाई पर ये व्यक्ति पहुंचता है। ऐसे ही अमेरिका का एक वैज्ञानिक प्रोफेसर लुइस एल्वारेज, जिन्हें 1968 में नोबेल प्राइज मिला, नोबेल लॉरिएट थे, कैलिफोर्निया के वर्कली यूनिवर्सिटी के फिजिक्स डिपार्टमेंट के हेड थे, और उन्होंने एक यंत्र बनाया, उसका नाम बबल चैम्बर रखा, जिसके ऊपर उन्हें नोबेल प्राइज मिला। लगभग 100-150 वर्ष पूर्व तो वैज्ञानिकों ने यह पता लगा लिया था कि द होल वर्ल्ड इज नथिंग बट मेयर वेवलेट्स वेवलेट्स वेवलेट्स। जैसा भगवान बुद्ध ने कहा कि सारा सब बेलों को पजलितो पजलितो प्रकंपितो प्रकंपितो, ऐसे वैज्ञानिकों ने यह पता लगा लिया था कि सारा संसार मेयर वेवलेट्स, तरंग ही तरंग है और कुछ नहीं है। ये व्यक्ति ये जानना चाहता था कि ये जो तरंग है ये एक सेकंड में कितनी शीघ्र गति से, उसकी फ्रीक्वेंसी क्या है पैदा होने की, समाप्त होने की। तो ये इस अपने यंत्र की सहायता से यही चीज पता लगाता है जब देखता है कि ये जो है 10⁻22 टाइम्स, ये जो स्मॉलेस्ट कॉन्स्टिट्यूएंट है, ये तरंग है, ये पैदा हो रही है, समाप्त हो रही है। ये दोनों वैज्ञानिक, एक भारत का वैज्ञानिक सिद्धार्थ गौतम उसी सच्चाई पे पहुंचता है, अपने अनुभव से पहुंचता है, और एक पश्चिम का वैज्ञानिक प्रोफेसर लुइस एल्वारेज, नोबेल लॉरिएट, उसी सच्चाई के ऊपर पहुंचता है अपने यंत्र की सहायता से कि ये 10⁻20 टाइम्स एक सेकंड में पैदा होती है, समाप्त होती है। लेकिन दोनों के सोच में, दोनों के आचरण में कितना अंतर है। एक व्यक्ति जिसने अनुभव से यही सच्चाई पता लगाई, वो बुद्ध हो गया, शुद्ध हो गया, शांत हो गया, धर्मवान बन गया, सारा जीवन लोगों को यही विद्या सिखाता रहा, लोक कल्याण कैसे हो, लोक दुखों से बाहर कैसे आए, इस पृथ्वी पर शांति कैसे हो, ये व्यक्ति यही सिखाता गया। भारत का एक वैज्ञानिक, महावैज्ञानिक। और एक व्यक्ति पश्चिम का एक वैज्ञानिक प्रोफेसर एल्वारेज, इस व्यक्ति का जो पहला परमाणु बम बना, अमेरिका ने जो पहला परमाणु बम बनाया, उसमें उस व्यक्ति का हाथ। और जब द्वितीय विश्व युद्ध हुआ, जापान के ऊपर परमाणु बम गिराया गया, तो ये व्यक्ति उस जहाज में बैठकर जाता है ये देखने के लिए कि मेरी ये जो खोज है इसका क्या प्रभाव होता है। उसका प्रभाव हम सभी जानते हैं। आज तक जापान में क्या स्थिति है, आज तक जापान में अपंग बच्चे पैदा हो रहे हैं। उस समय लाखों लोग मर गए, लाखों लोग अपंग हो गए, कई बीमारियों से ग्रसित हो गए। तो ये एक बेसिक अंतर है पश्चिम की और भारत की सोच का, पश्चिम के वैज्ञानिकों का, पश्चिम की खोज का, और भारत के वैज्ञानिकों का, भारत की खोज का। ये एक बेसिक डिफरेंस है। और यही एक जो भारत की अपनी सोच है, ऋषि मुनियों ने इसीलिए जो भौतिक जो खोज है उसके ऊपर अधिक महत्व नहीं दिया। और हमारी जो संस्कृति है, बेसिकली हमारी दोहन की संस्कृति है, और पश्चिम की संस्कृति शोषण की संस्कृति, शोषण की सोच है। हम प्रकृति के पूजक हैं। प्रकृति से अगर कुछ लेना भी है तो हम उतना ही लेते हैं जितना हमें आवश्यकता होती है, और वो भी हम याचना करके प्रकृति से लेते हैं। एक पेड़ लगाते हैं तो हम एक पेड़ काटते हैं तो 4 पेड़ लगाने की हमारा एक संस्कृति भी है, हमारा एक आदत भी है। हम पेड़ों की पूजा करते हैं, हम जंगलों की पूजा करते हैं, हम पानी की पूजा करते हैं, नदियों की पूजा करते हैं, पहाड़ों की पूजा करते हैं, पशु पक्षियों की पूजा करते हैं। ये हमारी संस्कृति है। पश्चिम की संस्कृति शोषण की संस्कृति है कि कैसे हम अधिक से अधिक इससे लाभ ले लें, कैसे अधिक से अधिक धन कमा लें। भारत की जो भूमि रही है वो ऋषि मुनियों की ऋषि रही है, और ऋषि का मतलब ही यही है कि जो रीत यानी कुदरत के कानून की ऐसा करते हैं, गवेषणा करते हैं, शोध करते हैं। और यही कारण है कि वो लोग हमेशा प्रकृति के साथ रहते थे। ऋषि, हो सकता है रिसर्च शब्द ऋषि से ही बना हो, ये एक शोध का विषय है, इसलिए उन्होंने मन को अधिक महत्व दिया, मन को सुधारने पर अधिक महत्व दिया। ठीक है, ये आज की सच्चाई है कि आज हमें पूरे संसार के साथ compete करना है। जो भौतिक रिसर्चेज हो रही है उनके साथ हमने compete करना है, वो बहुत आवश्यक है। और इसके लिए हम प्रयासरत भी हैं, हम कार्य भी कर रहे हैं। हम चंद्रमा तक हम पहुंच, अभी हाल ही में आपने देखा कि हमने अपना यान वहां पर, यहाँ पर सैटेलाइट वहां पर उतारा, विक्रम लैंडर की हेल्प से। हम सूर्य का हम अध्ययन कर रहे हैं। हमने हर क्षेत्र में हमने रिसर्च की है, हम आगे बढ़ रहे हैं, चाहे साइंस है, टेक्नोलॉजी है, एग्रीकल्चर है, हॉर्टिकल्चर है, मैकेनिकल इंजीनियरिंग है, कंप्यूटर इंजीनियरिंग है, आईटी सेक्टर है, हेल्थ सेक्टर है, सभी में हम आगे बढ़ रहे हैं। हम अपने हथियार, स्वदेशी हथियार हम डेवलप कर रहे हैं, अपने जेट फाइटर हम अपने तैयार कर रहे हैं, उनका निर्माण कर रहे हैं, चॉपर निर्माण कर रहे हैं, शिप्स हम तैयार कर रहे हैं। परंतु बेसिक क्वेश्चन वही है कि साइंस और टेक्नोलॉजी का हम कैसे सदुपयोग करते हैं। मनुष्य ही है जो अपने विवेक को जगा सकता है, अपने लाभ और हानि को देख सकता है। और ये जो अंधी दौड़ चली है उसमें हम देख रहे हैं कि ठीक है, लाभ तो हो रहा है, इन रिसर्चेज का लाभ तो हो रहा है, लेकिन लाभ के साथ साथ हानि अधिक हो रही है। अब आज की परिस्थितियां आप देख लो, जो जितना भी पॉल्यूशन है, गाड़ियों का है, इंडस्ट्रीज का है, सारा दिल्ली की क्या स्थिति है, हमारे जो बड़े शहर हैं उनकी क्या स्थिति है। अभी जो पीछे हमने देखा यहाँ, ये अभी 31 दिसंबर 1 जनवरी की बात थी, हिमाचल में लाखों गाड़ियां, शिमला, अकेले शिमला यहाँ पर ही 40,000 के आसपास गाड़ियां आ गई, सारी लाइफ स्टैंड स्टिल हो गई। और कितना पॉल्यूशन इन गाड़ियों का, मनाली, धर्मशाला, कुल्लू, शिमला कितना हुआ होगा हम देख सकते हैं। और इंडस्ट्रीज का अगर हम सही सदुपयोग नहीं कर रहे हैं तो कितना पॉल्यूशन, कितना वेस्ट जो है वो पॉल्यूशन के रूप में हम नदियों में छोड़ रहे हैं, एयर में छोड़ रहे हैं, सारी नदियां हमने पॉल्यूटेड कर दी। और इंडस्ट्री, सीमेंट उद्योग, हिमाचल में भी कुछ जगह सीमेंट उद्योग लगे हैं, तो उसका अनुभव हमें है। कितना वहां पर जो पार्टिकल्स हैं, जो डस्ट पार्टिकल्स हैं, वहां पर ठीक है संयंत्र लगे हैं, लेकिन उनका उपयोग नहीं करते। उसका खर्चा है, हजारों लाखों रुपए डेली का खर्चा है, उसको बचाने के लिए वो छोड़ते हैं, रात को छोड़ते हैं। तो उससे ऐसे ऐसे रोग पैदा हो गए, पशुओं में, मनुष्यों में ऐसे हो गए जिनका इलाज नहीं है, जिन बीमारियों का पता ही नहीं है। ऐसे रोग, वो अंदर सारा डस्ट अंदर जा रही है सूक्ष्म रूप में, इतने रोग हमने पैदा कर लिए। और बाकी आज मोबाइल का उपयोग हम कैसे कर रहे हैं, बच्चों की हमारी क्या स्थिति है, आज से बच्चों के मन की क्या स्थिति है, युवाओं के मन की क्या स्थिति है। आज से 20-25 वर्ष पूर्व हम सुनते थे कि जो पश्चिम के देश हैं उनमें वहां के लोग मनो नहीं, टनो स्लीपिंग पिल्स, ट्रैंक्विलाइजर्स खा के सोते हैं, ऐसी उनकी स्थिति थी। ये सारा ये कारण, यही जो भौतिक विकास हो रहा है, बेसिकली वही कारण था। और आज अब अगर भारत में भी अगर ये आप देखेंगे तो ये जो आप कोई हॉस्पिटल जाओ, ये जो इवन जो साइकेट्री जो हमारा डिपार्टमेंट है उसके बाहर जो लगी भीड़ है, आप देखेंगे जैसे मेडिसिन का जो ओपीडी है उसके बाहर तो चलो भीड़ होती है, दूसरे में तो भीड़ होती, लेकिन साइकेट्री डिपार्टमेंट के बाहर कितने युवा हमारे, कितने और दूसरे लोग वहां पर बैठे होते हैं। तो उनके मन की स्थिति से आप देख सकते हैं कि आज की जो विकास हो रहा है, ऐसा भी 25 वर्ष पूर्व होता ही नहीं था। लोग बड़े मजे से रहते थे, शांति से रहते थे। इस तरह का सारा प्रभाव, ये जो हम साइंस और टेक्नोलॉजी का उपयोग कर रहे हैं, ये बेसिकली उसी का प्रभाव है। ये कभी पश्चिम में ऐसा हुआ करता था 20-25 वर्ष पूर्व। आज भारत की भी ऐसी स्थिति बन रही है। 2500 वर्ष पूर्व का भारत जो विश्व गुरु था, पूरे संसार को सुख से जीने की विद्या सिखाता था, पूरा संसार शांति के लिए भारत की ओर देखता था। आज हमारी क्या स्थिति हो गई? बेसिकली ये जो बाहर का पोल्यूशन है, बाहर का जो क्लाइमेट चेंज है, ये भीतर की ही तो उपज है। मन के अंदर कोई लालच जाग रहा है, मैं ज्यादा से ज्यादा धन कमाऊं, मैं ज्यादा से ज्यादा इंडस्ट्रीज लगाऊं, दूसरा बिजनेस करूं, ये उसी का तो परिणाम है बेसिकली सारा। तो आज इसी के कारण, क्योंकि अज्ञानता बस हम इसका सही उपयोग नहीं कर रहे हैं, तो इसी के कारण आज ये संसार की ये स्थिति हो रही है। और हमारा चारित्रिक पतन बेसिकली हो गया है। आज नशे की जो स्थिति है, नशा जो हम आज चारों तरफ फैल रहा है, पहले आप देखते हैं 20-25 वर्ष पूर्व, 30 वर्ष पूर्व, जब हम छोटे थे या युवा थे, तो लोग नशा करने से, शराब पीने की शर्म महसूस करते थे। कोई पीता भी था तो वो छुप के पीता था। आज तो बाप और बेटा साथ शराब पी रहा है, नशा कर रहा है। आज आप शादियों में जाएंगे, पार्टियों में जाएंगे, सरेआम स्टॉल लगे होते हैं। सारी बेशर्मी की सारी हदें दूर हो गई हैं। और दुख की बात है कि आज महिलाएं भी नशा कर रही हैं। तो ये सारा का सारा इन्हीं चीजों का तो पतन है। जो हम भौतिक, जो हमारी रिसर्चेज हो रही हैं, उनको हम सही ढंग से प्रयोग नहीं कर रहे हैं, ये सारा उसी का तो है। ये क्लाइमेट चेंज तो है बेसिकली। और ये अंदर के क्लाइमेट का, माइंड का, जो माइंड के अंदर जो हमारे क्रोध पैदा हो रहा है, ईर्ष्या पैदा हो रही है, लालच पैदा हो रही है, उसी का तो दुष्परिणाम है सारा ये। और अंत में मैं ज्यादा समय आपका नहीं लूंगा। एक प्रोफेसर DS कोठारी, हम सभी जानते हैं, जो पहला जो हमारी एजुकेशन पॉलिसी बनी, भारत की एजुकेशन पॉलिसी बनी 1964 से 68 के बीच में, और जिसका हमारी उस समय की प्रधानमंत्री श्रीमती इंदिरा गांधी जी ने उसको लॉन्च किया था। उस समिति के चेयरमैन, अध्यक्ष थे प्रोफेसर DS कोठारी, और UGC के चेयरमैन भी रहे, फिजिक्स के प्रोफेसर थे। उनको चेयरमैन बनाया गया। तो उस समय पश्चिम के जो देश थे, ये इन रिसर्चेज में, जो भौतिक रिसर्चेज थी, इनमें ये विकसित हो गए थे। और जितना इन्होंने डेवलप करना था ये कर लिया था इन्होंने, इंफ्रास्ट्रक्चर वगैरह जो भी करना था, तो उतना वो डेवलप हो गए थे। अब उनकी जो मशीनरी थी, उनका जो मटेरियल था, वो किसको बेचे? तो उसको बेचने के लिए उनकी नज़र हमारे जैसे जो विकासशील देश थे, उनकी ओर उनकी नज़र गई। तो उन्होंने एक नैरेटिव सेट किया, डेवलपमेंट डेवलपमेंट डेवलपमेंट, विकास विकास और विकास, की विकास करिए, जितना कर सकते हैं अपने आप को विकसित करिए। तो क्योंकि उन्होंने मशीनरी बेचनी थी, अपना उनका धंधा था, उनकी सोच थी, मटेरियलिस्टिक उनकी थिंकिंग थी। तो उसी नैरेटिव के प्रभाव में कोठारी जी ने जो शिक्षा नीति थी, उसका जो शीर्षक रखा, वो रखा एजुकेशन फॉर नेशनल बिल्डिंग, एजुकेशन फॉर नेशनल बिल्डिंग। और 20-25 वर्ष के बाद, इस एजुकेशन पॉलिसी के 20-25 वर्षों के बाद, जब अगली एजुकेशन पॉलिसी बनने लगी, तो प्रोफेसर DS कोठारी जी को फिर पूछा गया कि अगर आपको ये दायित्व देते हैं तो क्या आप फिर से वही शीर्षक रखना चाहेंगे या बदलना चाहेंगे? तो DS कोठारी जी ने, अब उस समय वो अध्यात्म के संपर्क में आ गए थे, फिजिक्स के प्रोफेसर थे बेसिकली, लेकिन उनका इंटरेस्ट अध्यात्म में भी हो गया था। तो बोलते थे नहीं, मैं इसको बदलना चाहूंगा। बोलते हैं अगर मैंने इस एजुकेशन, जो पहली एजुकेशन पॉलिसी बनाई, इसका शीर्षक अगर रखा होता एजुकेशन फॉर कैरेक्टर बिल्डिंग, अगर मैंने ये शीर्षक रखा होता तो ठीक है, मेरा भाखड़ा बांध, मेरा ये भिलाई का कारखाना, मेरा ये जमशेदपुर का कारखाना हो बंद। हो सकता है ये कारखाने देरी से बनते, लेकिन अगर मैंने ये शीर्षक रखा होता तो आज ऐसे ईमानदार इंजीनियर पैदा होते, ऐसे ईमानदार लोग पैदा होते कि ये जो कारखाने बनने थे ये कम पैसे में बन जाते, कम खर्च से, आधे खर्च में बन जाते। और ये जो पुल बन रहे हैं, दूसरी चीजें बन रही हैं, ये इतनी जल्दी नहीं टूटते। इतनी ईमानदारी भारत में होती और आज ये भारत विकसित देश होता, विकसित राष्ट्र होता। तो एक ये सोच उनकी, DS कोठारी जी की, इतनी बड़ी सोच उस व्यक्ति की। और आज भी मैं तो ये कहता हूं कि आज भी, अभी भी हमारे पास समय है। हम अभी भी अपने विवेक से, ठीक है, compete करना है तो ये काम तो हमने साइंस और टेक्नोलॉजी ये सब तो डेवलप करना ही है, तो करना ही है। अपने आप को वेपन भी बनाने हैं, लेकिन सेल्फ डिफेंस के लिए करना है, ये सारा काम करना है। लेकिन उसका सदुपयोग अगर हम सही ढंग से करेंगे, विवेक पूर्वक करेंगे, तो हम अपनी जो भविष्य की पीढ़ियां हैं, हम हमारी जो आगे आने वाली पीढ़ियां हैं, उनके लिए हम एक ऐसी स्वस्थ पृथ्वी, स्वस्थ प्रकृति छोड़ के जाएंगे। नहीं तो आगे की जो पीढ़ियां आएंगी, अगर यही स्थिति रही तो वो हमें कोसेंगी कि हमारे पूर्वजों ने हमें क्या दिया, हमें विरासत में क्या दिया। एक रोगी पृथ्वी, एक रोगी प्रकृति, और शायद इस पाप से हम नहीं बच पाएंगे। तो आज मैं, यही मेरे मन में था कि मैं अपनी बात आप लोगों के सामने रखूंगा। तो आप लोग युवा हैं, आप लोगों ने आगे जाना है, और इस सोच के साथ अगर हम काम करेंगे, मुझे लगता है कि हमारा क्लाइमेट भी बचेगा, हमारी समाज भी बचेगा, और देश भी बचेगा, पृथ्वी भी बचेगी। इन्हीं शब्दों के साथ अपनी बात समाप्त करता हूँ। धन्यवाद।
Every component of the art, so as to have a sustainable ecosystem. Thank you so much.
ठीक है, मैं लीज
He has more than 5 publications written down here. We welcome sir online for the lecture. Sir, you may proceed with your lecture. Yes, sir. Yes, sir. It's audible, it's visible.
A very good morning to all. Myself, and my title of my invited talk is Exploration of Versatility of Homogeneity for the Synthesis of Beta-Carbolin-Based Privilege Scaffolds. Now, first of all, what is beta-carbolin? Beta-carbolin is basically a tricyclic framework that is made of indole ring fused with ring, indole ring fused with pyridine. In this tricyclic framework, two nitrogen atoms are present. This is the way we number it: 1, 4. So there are two nitrogens at N2 nitrogen and N nitrogen. Our research group is mainly working on this natural product, that is 2-formyl beta-carbolin. This is also known as Fumigen C. It is basically isolated from rootwood of Picrasma costoides, and it is a natural product. So now natural products are so important. The reason is that natural products serve as a guiding principle for development of drug, for designing of new drug candidates, and these alkaloids are basically, and specifically beta-carbolin alkaloids, are ubiquitously present in nature, including plants, marine organisms, insects, mammals, even human beings. These are present. Specifically, these beta-carbolin alkaloids display anti-cancer properties, and their mechanism of action is that they intercalate into DNA. They inhibit cyclin-dependent kinases, topoisomerases, and other kinases involved in cell division. Due to their immense significance in medicinal chemistry, a variety of beta-carbolin derivatives have been prepared and in research. These are just some example of beta-carbolin-based drug molecules. This is one of the recently developed drugs, cipargamine, that is an antimalarial, and these are the other commercial drugs. And these are the biological targets. They show their anti-cancer activity. Now, why we are working on one beta-carbolin? Reason is that beta-carbolin framework is represented by a large. These are just some example of beta-carbolin C1 substituted natural products. These are beta-carbolin N-fused natural products. These are some beta-carbolin based bis-carbolin containing natural products. You can see there are two beta-carbolin rings present within the same molecule. Either they are fused or they are linked through a tether. So these beta-carbolin based alkaloids are biologically very important, and they have potential to be developed as a drug candidate. Now we are specifically working on this natural product. Now what is the reason? You can see that this molecule, it is a tricyclic framework. It have formyl ring at C1 position, formyl functionality at C1 position. This it is a highly electrophilic site. Along with this, there are two nucleophilic sites in the form of this N2 nitrogen and N9 nitrogen. And there are several sites for diversification in the C ring and A ring. So we can smartly explore this molecule. We can block this N9 site and N2 site, and selectively we can achieve the synthesis of beta-carbolin C1 tethered carbocycles and heterocycles. In other way, we can achieve C1 N9 cyclization, and we can achieve the synthesis of other natural products and natural product mimics like anthenone derivatives, or we can achieve C1 N9 cyclization and synthesis of other natural products like harmicine, homophosphoglycine can be achieved. Now, first of all, we developed a gram scale synthetic procedure for the synthesis of this natural product. and its synthesis was achieved from commercially available L-tryptophan via expected Spengler reaction with the dimethoxyglycol under aqueous condition that furnished this 3-carboxyl tetrahydrobeta carbolene, and further oxidation of this C ring was achieved with NCS in DMF and chlorosuccinamide in DMF, which resulted in decarboxylation as well as aromatization or oxidation, resulting in formation of 1-acetyl beta-carboline 1-acetals. Further, this demasking of acetal was achieved with aqueous acetic acid that resulted in formation of 1,4-methyl beta-carboline. Ma'am, I just want to know, my slides are moving.
Yes, sir.
Yes, sir.
Yeah. Then we explored the synthetic application of this natural product, and we treated it in presence in condition. It resulted in formation of beta-carboline and fused imidazole derivatives. So C1N, this structure was confirmed with the help of X-ray crystallographic data. Again, amino acids containing aromatic as well as aliphatic substituents like glycine, alanine, serine, valine, leucine, isoleucine, methionine, flavin, alanine, etc. When this reaction was performed with L-serine, which is a binucleophilic amino acid, it resulted in formation of this pentacyclic framework. After formation of this beta-carboline and fused imidazole, another intramolecular cyclization was forced and resulting in formation of this pentacyclic scaffold. So a series of beta-carboline and fused imidazole derivatives were prepared, and it was found that these were highly fluorescent in nature. So their photophysical properties were evaluated, and a quantum yield up to 50% was obtained. And this is the proposed mechanism. First, this formyl functionality and this amino functionality in presence of iodine undergo condensation, resulting in formation of imine type of intermediate or iminium type of intermediate. Then in presence of sodium bicarbonate, it undergo decarboxylation, loss of this CWH group occur as CO2, and it results in formation of azomethane yelid. This isomerizes and it undergoes 6-pi electrocyclization to generate this beta-carboline and fused imidazole derivatives. In another study, we wanted to react this 1,4-methyl with nitromethane in presence of ammonium acetate in acetic acid, and we were expecting this product, a nitrostyrene type of intermediate. And we further wanted to explore is for the synthesis of this eudiostomine U skeleton. And however, when we performed this reaction in actual, we obtained this natural product, this beta-carboline based scaffold, and a retrosynthetic analysis revealed that basically 2 molecules of 1,4-methyl beta-carboline is generated in situ from ammonium acetate undergo intramolecular cyclization to generate this bis-carboline derivatives. And then optimization studies revealed that with 2.5 bullet of ammonium acetate in acetic acid at room temperature within 2 to 4 hours, these complex type of scaffolds can be easily generated. We found that here in previous step, the reaction was intramolecular. 2 similar type of 1,4-methyl beta-carbones were participating in reaction. But we found that reaction can also be executed via cross condensation. 2 different type of aldehyde can be reacted with 1,4-methyl beta-carboline. However, the another participant aldehyde must be more electrophilic than this beta-carboline aldehyde. Only in undergo cross condensation, and these beta-carboline and fused imidazole derivatives can be obtained. The strategy was applied for the synthesis of functionalized beta-carboline and fused imidazole derivatives also, and in this case, quantum yield up to 26% was obtained. Then we thought that why can replace ammonia with aniline or 2-pyridine derivatives. So when the same reaction was performed with 1,4-methyl beta carboline, we obtained this beta carboline N-fused imidazolium salt as a with acetate ion as the counter ion. In this case also, the quantum yield was evaluated and up to 85% quantum yield was obtained. These molecules were highly fluorescent in nature. Depending upon the degree of conjugation, these molecules were like blue emitting, green emitting, or yellow light emitting scaffolds. In another modification, we also found that instead of 1,4-methyl beta carboline, even beta carboline acetal derivatives can also be used for the generation of these beta carboline N-fused imidazole derivatives or bis carboline derivatives. However, reaction works well when ammonium chloride is used as one of the reactant. Then, in continuation of the previous study, we thought that why we cannot explore phenyl glycol derivatives instead of simple aldehydes, because phenyl glycols have two electrophilic sites, CO and CHO. We were expecting that it is more reactive than this, and we will obtain this product. Cross condensation product will be obtained. However, when we perform this reaction with ammonium acetate in methanol, we don't obtain this product. Rather, we obtained beta carboline C1T3 imidazole derivatives and D1 beta carboline CT3 imidazole derivatives. So we can see that by modifying the reaction conditions, just replacing the acetic acid with methanol as a solvent, the regioselectivity and chemoselectivity is changed. When we use ammonium acetate N-fused and acetic acid as a solvent, N-fused imidazole derivatives were obtained, while when other protic solvent was used, beta carboline C1T3 imidazole derivatives were obtained. Okay, so in another study, we achieved the synthesis of a molecular hybrid of beta carboline T3 with the butyrolactone, having an exocyclic double bond. It is pertinent to mention that this butyrolactone framework as well as beta carboline framework both are represented in large number of natural products, and they display potent anti-cancer activities. So we designed this molecular hybrid and we prepared it for their synthesis. We explored these cinnamyl bromide derivatives that were prepared from Morita-Belli-Shillman reaction, and in presence of indium under semi-aqueous condition in THF water, when we executed this reaction in presence of indium, in situ this homoallyl alcohol was formed, but in situ it underwent cyclization to generate these beta carboline T3 beta lactone derivatives with trans-stereochemistry, and it was the first report where trans-stereochemistry was obtained. And another interesting fact is that this reaction works well under semi-aqueous condition when water is taken as a solvent. In dry THF, this reaction does not take place. And in fact, it is found that water acts as a dual activator. It acts as an electrophile as well as a nucleophile in this reaction. These are the proposed transition states, and structure was again confirmed with single crystal X-ray data. Then we explored this natural product and its derivative for the synthesis of beta carboline C1T3 benzimidazole derivatives by reacting with 1,2-orthophenylene diamine and its derivatives. In this case, we obtained beta carboline C1T3 benzimidazole derivatives when 2-aminothiophenol or 2-hydroxyphenol 2-hydroxyamine were obtained. Benzothiazole and benzoxazole derivatives were obtained. However, you can see that in this case we can prepare only this type of derivative where there was no diversification in this phenyl ring. That is that 2-aminothiophenol derivatives, only few derivatives are costly available, and they are very costly except 2-aminothiophenol. So it was decided to develop an alternate methodology, and we explored the where in situ sulfur can be inserted. There we carry out the reaction of 1,4-methyl beta carboline with arylamines in presence of elemental sulfur and using iodine as an activate in DMSO as a solvent. and we obtained a large series of beta carbolin N-fused benzothiazole derivatives. So the strategy was also applicable to the carbazolamine, naphthylamine, arylamines. In this case also, the quantum yield was calculated and up to 92% quantum yield was obtained. Then we explored this sulfur insertion strategy for the synthesis of thiamide derivatives. When this 1,4-mile beta carbolin was treated with the amines, aromatic amines or aliphatic amines or 2-aminopyridines in presence of sulfur under catalyst-free condition and base-free condition, we can achieve these beta carbolin 70 thiamide derivatives even with pyridine conjugates, very good yield in 58 to 93% yield. Again, this strategy was also explored for the synthesis of LNG-butene analog when 1,4-mile beta carbolin was treated with tryptamine in presence of sulfur in DMF at 70 degree. LNG-butene analog was obtained. Again, see carefully, here the solvent is DMF 70 degree. However, when we use the base K2CO3, no thiamide was obtained. In fact, we obtained these bis carbolin derivatives. In this case, when base was used K2CO3, in fact, this cleavage of C and bond takes place. Ammonia is generated in situ, and that acts as a source for the formation of this bis carbolin derivatives. We again explored the sulfur insertion chemistry for the synthesis of benzothiophenone derivatives, where 1,4-mile beta carbolin was treated with the 2-nitroacetophenone derivatives. First, the Claisen-Schmidt condensation reaction or aldol condensation reaction was performed. That resulted in formation of nitrochalcones. Then they were treated in situ with sulfur in presence of triethylamine and DMSO. Here, the triethylamine acts as a sulfur activator. Again, we also developed a one-port approach for the synthesis of these benzothiophenone derivatives, where in situ the chalcone was prepared in KOH DMF, then methanol was KOH and methanol. Methanol was evaporated and content was dissolved in DMSO and sulfur was added. Hanji ma'am. Hello. Okay, ma'am. Okay. So we have further explored this strategy for the synthesis of benzothiophenone derivatives. And again, this alkaloid was used for the synthesis of another beta carbolin phenolene derivatives, nitramarine analogs. And recently, we also explored it for the synthesis of A3 coupling, where beta carbolin infused pyrrole derivatives were obtained. That are basically the harnessing mix. So overall, by using this single net product, we have synthesized a diverse chemical library and several net product mix. By using Barbier type alylation reaction, decarboxylative amination, sulfur insertion strategy, oxidative amination, and various multi-component reactions. With this, I would like to thank the organizers, especially Dr. Nisha, Dr. Sweta Singh, and Dr. Yunis, and my colleagues and my PhD students. Thank you all. If there is any question, you are most welcome.
Research contributions in the field of chemistry for empowering society. Thank you so much.
Thank you.
It gives me an immense pleasure to welcome our guest of honor, the most eminent personality, Dr. Prithpal Singh, Vice Chancellor, Shri Guru Granth Sahib World University, Fatehgarh Sahib. He is a well-known name in the field of chemistry. He has been specialized in inorganic chemistry. He has made enormous contributions in the field of chemistry. He is having rich experience in teaching and research. He has added to the field of chemistry in the form of various research publications. So we are highly thankful to Sir that he has graced us with his presence online. I think to validation he may not be present personally, so I welcome sir on this occasion. Sir, this is 3-day national conference going on the title Empowering Sustainability, Bridging Science, Technology and Climate Resilience 2024. We welcome you, sir, for the address.
Respected Vice Chancellor Sahab, Santwa University, of KT, delegates attending the conference online and offline, and dear students, a very good morning to all of you. First of all, I congratulate Santwa University, Vice Chancellor Sir and its staff for organizing this conference on a very relevant theme of global climate. Further enhance the water demand, mainly due to the increased evaporation and transpiration by plants. A recent study showed that a 1 degree centigrade rise in temperature increases the residential water demand by about 3.78 liter per person per day. Increasing global temperatures due to climate change may impact the water cycle by influencing the extent of precipitation. Increasing global temperatures cause water to evaporate in larger amounts, which will lead to higher levels of atmospheric water vapor and more frequent, heavy, and intense rains in the coming years. This will lead to more floods, and the runoff will pick off the fertilizers and pesticides on its way, and ultimately these pesticides and fertilizers will enter into the larger water bodies like rivers, seas, and oceans, and ultimately this will lead to the growth of algae in these water bodies. So these algae have a tendency to block the penetration of sunlight in the water stream, and as a result, because of shortage of oxygen in the water, as well as the entry of toxins into the water bodies, will lead to the death of aquatic animals, and these adverse chemicals, they will enter the whole of the food chain, and this will endanger the human life. With increase in temperature, the freshwater glaciers around the earth will begin to melt at an unsustainable rate, which will result in rising sea levels. Saltish water can more easily contaminate underground aquifers. In the northern hemisphere, snow is the only freshwater resource, and with the decrease in rain in snowfall, the availability of water in the local reservoirs will decrease. That will directly impact the agriculture activities in this northern hemisphere. Water resources planning and management in the 21st century is becoming an increasingly difficult task due to conflicting demands from various stakeholders, like increase in population, rapid urbanization, projected climate change, and consequent changes expected in the hydrological cycle, the use of toxic chemicals in various land use activities, and the increasing incidence of natural disasters. Among these, the impact of global warming and consequent projected climate change on water resources have emerged as a matter of grave concern. The much debated greenhouse effect is basically essential to maintain life on Earth, but the increased industrial activity has altered this balance, and as a result, the greenhouse gases, they are posing a great challenge to the humanity in the form of climate change or global warming. The Intergovernmental Panel on Climate Change, set up by United Nations in 1998, in its fourth assessment report in 2007 stated that the process of climate change is happening in all the continents and oceans, and that most of the observed increase in temperature is a result of the increasing concentration of greenhouse gases in the atmosphere due to human activities, mostly due to burning of fossil fuels and the deforestation, both of which cause emissions of carbon dioxide and the other greenhouse gases like methane and nitrous oxide. Climate change is expected to significantly enhance the current stress on water resources resulting from population growth, economic factors, and land use changes, including urbanization. There is also a high probability that many semi-arid areas will become drought-hit, and the drought-affected areas are projected to increase in extent, with the potential for adverse impacts on multiple sectors, including agriculture, water supply, energy production, and health. Regionally, large increase in irrigation water demand is projected as a result of climate change. As per SDG report 2022, about 2 billion people worldwide don't have access to safe drinking water today, and roughly half of the world's population is experiencing severe water scarcity for at least a part of the year. These numbers are expected to increase due to climate change and population growth. The climate change, population growth, and increasing water scarcity will put pressure on food supply. Basically, 70% of the fresh water is used for agricultural purposes, and only 30% of water that is used for human consumption. And a person's daily needs are met by the food which is produced by consuming about 2,000 to 5,000 liters of water. Since 2000, flood-related disasters have risen by 134% compared with the two previous decades, and most of the flood-related deaths have been reported in Asia. And similarly, the duration and number of droughts also increased by 29% over the same period, and the most of the drought-related deaths occurred in Africa. Though India has achieved self-sufficiency in food grain production due to green revolution, but it has brought a host of environmental challenges like loss of soil fertility, waterlogging, ground and surface water contamination, intensified pests and diseases, and socio-economic problems like increased farm input prices and regional disparity. In addition to all these, climate changes has added new dimension to existing problems by posing a significant threat to Indian agriculture in general and food security in particular. Basically, it has been observed that due to frequent droughts since the last half century, the contribution of agriculture to GDP has been decreased by 0.25%. India is basically an agrarian economy, and 85% of the farmers, they don't have financial resilience. If we take the case of Punjab, of the 137 blocks, about 108 blocks are in danger, and because of excessive pumping of water from the groundwater due to increased demand of water for agriculture, the most of these blocks have come in the danger zone, and in the coming years, there will be a lot of pressure on the drinking water supply as well on the water requirement for the agricultural practices. So accordingly, there is an urgent necessity to take a call in this regard to control the climate change. Basically, it is not the duty of any single individual or any government. It is the collective responsibility of all the individuals and the nations to contribute towards the tackling the climate change. Basically, since the pre-industrial area, there has been an increase of 1.1 degree centigrade rise in temperature, and it is expected that by 2050, if the current activities went on unchecked, this increase in temperature will amount to 2%, 2 degrees centigrade. But by the various bodies are making efforts that this increase in temperature is restricted to 1.5 degrees centigrade, and this will lead to about 50% adverse effect on the water supply demand. If we talk in the local context, We have seen the recent floods in July that has devastated the two states like Himachal Pradesh and Punjab, and the increase in rainwater has been due to the effects of climate change, and also in the current season we are having an intense winter wave, and we have not received a single drop of rainfall in the winter monsoon. So it is time to become aware that how to check this climate change, how to reduce the dependency on fossil fuels. One is the way to have dependency on the renewable energy sources. As the government has earlier resorted to green revolution, they offered the paddy and wheat cycle to the farmers. The time has come that the government provides an alternative to this paddy and wheat cycle, so that the alternative cropping patterns can be followed by the farmers. And also the area under horticulture should be increased, because the horticulture activities consume almost 25% of water as is needed for the paddy and wheat cycles. Also, we need to adopt practices for conservation of water, like drip irrigation that has been adopted by Israel in a very successful manner. So it becomes the duty of all the governments and every citizen to contribute to check the global warming, and also increased forestation. Wherever the empty spaces are available, we must have forestation in those areas, so that the effects of climate change can be addressed. So not taking much time, I once again thank the Vice Chancellor sir and the staff of the Sant Pathfind University for giving me chance to address this august audience. Thank you.
Concerns related to environment, such as global warming, depleting water resources, deteriorating environment due to human activities. Your concerns are quite serious, and we really need to take steps so that we can conserve our environment. Thank you so much, sir, for your presence with us online. Thank you so much for sparing time for us. I welcome Secretary Sir, Vice Chancellor Sir, Society member Sardar Paramjit Singh Ji, Sant Baba Pag Singh Memorial Charitable Society, Registrar Sir, to the third day of the three-day national conference on the title Empowering Sustainability, Bridging Science, Technology and Climate Resilience 2024. I also welcome our resource person, Dr. Omkar Singh Barach, Associate Professor, Department of Zoology, Punjab University, Patiala. Thank you so much, sir. We welcome you. Continuing with our technical schedule, I am pleased to present Dr. Asim Kumar Jana, who has joined us online. He is professor at Dr. B.R. Ambedkar National Institute of Technology, Jalandhar, with PhD in biotechnology and 30 years of rich experience in teaching and research. Dr. Jana has been specialized in biotechnology, bioprocess engineering, and enzyme technology. His impactful contributions include 78 research papers in reputed national international journals, more than 35 book chapters, and an edited book. As a fellow of Institute of Engineers, Kolkata since 2018, and a life member of Institute of Chemical Engineers, Kolkata since 1998, Dr. Jana brings a wealth of expertise to our conference. So thank you so much for joining us online. Now we would request to please present your presentation. So you can proceed with your presentation. Yes, sir, you're audible, you're visible.
context. So I am going into my presentation. All right.
Yes, sir. Mute your mic.
Just a minute, maybe some.
Please unmute.
Mute your mic. So yes, it is visible. Yes, sir, you can proceed with your presentation.
Hello.
So you
Am I
are
audible?
Yes, sir, you are audible.
Hello.
Yes, sir, it's fine. Please proceed with your presentation.
Say blood.
You are audible, sir.
Hello.
Yes,
Yes, sir, you are audible.
Slow online. Mein.
You are audible. We can listen you.
So here I will directly go into my presentation. I'm sorry for the interruptions.
it's okay.
It is about the production of alcohol from cellulosic biomass. Actually, all of we have heard about the production of alcohol from the sugars, but now we have to go for an alternative sources because it is creating a conflict. So before that, in fact, there is a critical steps for pre-treatment of the biomass for delignification. Actually, I am not going into details. So delignification is the removal of the lignin to expose the cellulose first. Then it will be converted into the sugars, fermentable sugars, which are pentoses and hexoses. So just if you look at this, actually it is a newspaper cutting from the Tribune from 17th, day before yesterday itself. The government is how much actually concerned about these things. Recently, they have brought the policy, the 50% export duty on the molasses to boost the ethanol production. Now there is actually, most of us know, the ethanol is the chemical which is most sought after by the governments because it is going to be a substitute of the petroleum. Now consequent benefits are obviously known to everybody. So you see some basic energy facts we should know. We should know is that actually all energies are not equal. We need energy, how vital it is, but energy should serve the purpose, not only the energy. In fact, it should serve the purpose of heating, lighting, and the mobility. Now you see, out of this mobility, petroleum 97% and rest is ethanol on the present context. Now what is happening, this all BTUs are not equal, and because all energy does not have the same value or utility. Just if you see, the liquid fuel and not the energy is for serve the purpose of the mobility. Now if you see in terms of the energy, different sources again cannot be treated as equal. If we look at it, what are the sources of energy in the present days? It is the coal, natural gas, and the petroleum. Now, you see, the US and China have the largest quantity of the reserves. Again, in the natural gas, it is the Canada and Mexico have the maximum. And in case of the petroleum, actually 60% of the petroleum are being imported in case of our country. And second thing, oil has the disadvantage. Oil is used as a political weapon. Oil revenues finance the international terrorism. These are the some of the problems. And the most concern the people are now talking about the climate security. The petroleum dependence does not take care of the climate security. Another thing is the economic security, international security, or the world stability. So in this case, just this picture gives a glimpse. If we do not have the petroleum, the whole world stops. Now can you imagine from this line of vehicles, which will be frequently, if you go to Delhi, even in our Jalandhar also, actually all these vehicles are run, in fact, only by the petroleum. Now it is, in fact, if you side of it, if you see, if the petroleum is not been there, it would be drawn by the horse. Now what is happening in the, actually, now the question of coming is the topic of your conference, that is the sustainability challenges. Among the sustainability challenges, actually, we have to diversify the transportation fuels and the end strategic role of the petroleum. Second thing, if we go for it, we also have to provide the food for the growth and wealthier people persons. And also we have to control the greenhouses, provide the economic opportunity to the rural peoples. So these challenges remains while we go for the sustainability. Now how it could be dealt with, actually, first thing we have to deal with that you have to decrease the demand for the petroleum. That is point number one. We should have the better mileage for the cars and least amount of uses. Another thing is alternative is that we have to go for the petroleum from the sources which are generally not being used. That could be oil sales, the super heavy oils. These are currently not being used. And the last one is the biofuel. Biofuel are which is coming as the biodiesel and the ethanol from sugar, from corn, and from cellulosics, actually, which is not currently not being done. From the sugar and corn, which is being used, ethanol, or mostly, in fact, more than 98% are being produced from the sugar and corn. So in the beginning, I told you that's why the molasses has become such an important component nowadays, the government has to regulate it so that it is not being exported. In fact, other things also nowadays, mostly we have been observed. That is, the thing is that the sugar prices are being controlled, because if it is not being controlled, the very large quantities of will be diverted into the form of the ethanol, which is more profitable for the sugar industries. So that's why there is need for the strict control how much the sugar will go into the ethanol and how much sugar will go into the other products, basically the sugar. Now, that's why it is the question of coming of biofuels, including the cellulosic ethanol. In fact, already I have shown you the need of it. Now, this is the global biofuel market forecast. You see, the lignocellulosics will contribute in future. In fact, the largest quantity of the ethanol. Just it is the reason that why cellulosic ethanol. The conventional ethanol has the problems of food versus fuel problem, because once you do not have the control how much the food will diverted in the form of the fuel, in fact it will create an artificial scarcity, because conversion to ethanol in today's context are more profitable for the industries. Now you see ethanol, actually the basic things, there are two types of sources. Ethanol is that one is the biological conversion, another is the synthetic conversion. Now presently, in fact, 10% blending is been done practically. Now government is trying to achieve it up to 20% at the earliest. Another source is the biodiesel. The problem with the advantage with the ethanol is that it is the source independent. From wherever you produce the ethanol, it remains the same composition. But in case of biodiesel, actually it is a fatty acid methyl ester. It is dependent on the source. These are the generally common sources are being actually, that is oils. The vegetables oil converted into the biodiesels. Biodiesels are also being used as the additives with the petroleums, but again, there would be some variation in the compositions from where it is being manufactured. But in case of ethanol, it is, in fact, the composition remains same. Another type of biofuels which are also being produced, actually, which are biomass derived, but it is through in the form of actually pyrolysis. The heat content will be reserved. First, it is being gasified, maximum calorific value will be retained, and finally it is converted into the liquid fuel. So out of this gaseous component, it's called the syngas. Syngas not only could be used for the fuel, and also it could be used for the sources of various type of chemicals. In fact, we also need the various type of chemicals which are also petroleum derived. Now you see what we are getting. Just I have listed out. One is the ethanol, another is the biodiesel, and the converted biomass, that is through the pyrolysis. Just I have mentioned already, the source of biodiesels are soybean, palm oil, rice, cottonseed, rapeseed, etc. Ethanol sources, already I have mentioned the corn, beets, cane, potatoes, etc. But cellulosic ethanol mainly from the wood, grass, stalk, etc. Now this is it could be the cycle like this. While from the plant sources, which is being converted into the fuel, actually it is generating carbon dioxide, then it is further being absorbed by the plant sources. So this is the cyclic. In fact, the cycle is being complete. So it is a very much the sustainable sources. Now this is the picture of a corn, in fact, which is just I told the present day, the maximum amount of corn is being used for the purpose of, this is the flow, in fact, how the corn is being processed for the conversions of ethanol and starch and high fructose corn syrup, which is being used for the sweetener industries. So this is in fact, this can replace the sugar itself. In fact, all of our beverages are being used the high fructose corn syrup. So this is a simple fermentation process. I told that glucose is fermented to ethanol. So this is the pathway. First the pyruvate, then acetaldehyde and ethanol. Fermentation. Now this is an overall picture how the different biomass can be converted into the different type of fuels. I have given already that gasification, pyrolysis, the dissolution, the liquid phase process. This is the saccharification of the corn, already just I have mentioned. Then enzymatic fermentations which give the ethanol. So you can have the jet fuel, diesel, gasoline or ethanol. In fact, these are the some of the advantages and disadvantages. I'm not going into these. Multiple feedstocks. The conversion into ethanol actually presently now are dependent on the limited sources. But if you go for the switch over to cellulosic ethanol, you can use the multiple feed sources, which could be trees, grass, agriculture residues, or the energy crops. Why the cellulosic ethanol? Actually, to avoid the food versus feed controversy. Now, this is the Indian scenario of the biofuel productions. Just I have told, if you look at the second picture, this is showing the blending share, the red line. The blending share is trying to achieve up to 20%. Presently, we have already achieved at the 2020, already we have achieved the 10%. Now, government is searching or actually trying to achieve the 20%. Regulation has already been passed, but there is a problem, not sufficient ethanol are available. I have mentioned it earlier. This is the world market. In fact, now what actually happened earlier, in fact, fuel processing, the picture is like this. Earlier, the oil prices were lower and processing costs were higher. But gradually with the time, what it happened, the oil prices has increased and processing cost has reduced. Now overall cost has increased. Now what is happening in case of the biofuels? Now biofuels are cheaper, but the processing cost is very high. Now our objective is that biomass price will remain the same, but processing cost should be reduced. So then only it is possible to have the competition with the present day petroleum prices. So this is the biggest hurdle. Indian scenario of the biofuel productions, I have already given you the glimpse. Actually, the estimated investment of the 12 biorefineries is expected to come with a price of 10,000 crores, and it is expected that 35 to 40 crore liters of ethanol to be produced in the year of very soon. So this production of actually the cellulosic ethanol, which is the alternative from the starch-based source or the sugar-based source, it is called the 2G ethanol. You must have seen the 4G, 5G, but this is called the 2G ethanol. यार तुम लोग क्यों बार बार आते जा रहा है? मैं कह रहा हूँ कुछ लेक्चर रखो छोड़ो. So this actually I already have told you the different type of potential sources of the biomass for the 2G ethanol. I have shown you that 4 categories: agriculture residues, energy crops, wood and paper waste, now the solid waste or organic wastes. The problem with cellulosic ethanol is the lignin. Actually, you see the complex structure, which is the heterocyclic, and the rod-shaped structure are basically the cellulose. Until unless you break the lignin, the cellulose is not accessible. After once you get the cellulose, you have to further degrade the cellulose. Now this is the picture. Once the cellulose is been exposed, only it is now amenable for the conversion for the further process. The biggest problem with the conversion of the lignin, actually destruction of the lignin, to keeping the cellulose intact. You should not destroy the cellulose, but you should break the lignin. Lignin is one of the toughest material, in fact, in the nature on the present day. These are the various quantity of biomass which are possible to, in fact, these are calculated in metric tons. In fact, it is a very, very large quantity, almost inexhaustible. This is an average composition of the cellulosic biomass. This is the cellulose, hemicellulose, lignin, and other components. If you see it, actually the cellulose is approximately around 45%, hemicellulose are around 25%. Only the sugar portion can be converted to ethanol. This is the cellulosic structure. Once you break it, you will get the simple sugar. This is the hemicellulose. Now these are the components of the lignins. Actually, there are three basic components. I'm not going into details. Now there is a complex structure which is basically the outer layer. The lignin portion is the outer layer. That's why it's protecting the cellulose. Now before to just I have given you the importance of the how to break the lignin structure to access for the cellulose. You need to have a pre-treatment process. In fact, this pre-treatment process will give you the cellulose. Then you have to break the cellulose, that is, you have to hydrolyze it to get the hexose or pentose. Then you have to go for the ethanol through the fermentation. Now, how do you break this lignin structure, or how do you get the cellulose? There are various treatment processes, pre-treatment processes are there, which are acid hydrolysis, alkali hydrolysis, physical treatments, physicochemical treatments, biological, the last one, biological or enzymatic treatments. So these are the different type of treatments are required to break the lignin. So this is just a schematic diagram how it is been. You see the outer layer is been lignin, actually, which is being protecting the cellulose. Now the objective is that to get the maximum break the lignin to maximum extent. Now simultaneously protect the hexose to the maximum extent. So you have to select the process. Now this is the yeast metabolism, where xylose and glucose are being used and finally converted into ethanol through the fermentation. So this xylose and glucose are coming actually after breaking of the cellulose and hemicellulose. So these are actually different solvents which also could be used at the room temperature. Now this is a process actually using an ammonium explosion technique. While you are putting at high pressure and temperature simultaneously in presence of ammonia, actually the biomass, the lignin could be broken down and finally ammonia could be recovered. In fact, these are at the different treatments, how the different biomass actually will give you the amount of sugar conversion. It is the glucose conversion. Now the objective of the biomass processing has to be low cost treatment, that is the low investment, low chemical uses, low energy intensity, and high yield. So these are actually some of, if you see, I have listed out the different process, the liquid hot water, weak acid, alkaline process, organoslov, these are listed out, and what are the advantages. Actually, it secretes the different type of enzymes and it has ability to degrade the lignin. So you don't need to use the chemicals. Now the different lignolytic enzymes, actually, you see lignolytic enzymes which has the ability to degrade the lignin, cellulolytic enzymes which has the ability to degrade the cellulose, and this is the yeast. Now, actually, the fungal species does have both these type of ability, lignolytic and cellulolytic. So while you grow the fungus over the wood biomass for its treatments, actually you do not need the any chemicals or high temperature or pressure. You can do it almost in the natural conditions. But with the use of these enzymes, the fungal species can degrade and convert the sugar, convert the cellulose into sugar, fermentable sugar, and in the next stage and the next process, you can convert into ethanol. So this is actually one of my students did some work. Actually, he tried to isolate the different type of fungal species, and he tried what are the enzymes are which are produced. All the fungal species do not produce the same enzymes. He tried to establish the different type of enzymes and have a combination of the fungal species to get the maximum lignolytic abilities and exposure of the sugars. So this is the guaiacol test for the lackage ability. This is one enzymes. Lignolytic ability using the Congo red dye test. Pyrogalal test for the ability to secrete my paper or student did work. So this is another test, actually two different combinations, actually two different type of fungal species could be tried for the better yield of the exposure of the cellulose. So this is a hypothetical mechanism how the degradations are done using the enzymes. Now these are the different items, actually another things, not only the fuels, you see different items are made of the different chemicals. Surprisingly, these chemicals are also derived from the petroleum. Now there could be again for the different manufacture of chemicals, it is also possible to have not only the fuels, these chemicals are also possible to produce using the biomass. Everybody needs the chemicals, but there are the problems of raw materials that is coming from the same petroleum, the process of chemical manufacturing, and the product. In fact, now these are the so much the waste and finally going into these things and of no use. Waste is the tomorrow's resource. You see, the same resource can be recycled. Now chemicals from the food waste. If you look at these, we can produce these much chemicals under once you convert into the sugar. In fact, it opens a chain of reactions, other possibilities. Now this is the sources. You see, sugar is from the food waste, you can produce the sugar, ethanol, starch, collagen, cellulose. So this is the first layer. You can further go into conversion, another layer of chemicals. Now, if you look at this picture carefully, if you have an orange, the 50% juice and 50% is the waste. Now, this out of waste you can convert into the biochemicals, biofuels, the biomaterials. This is the petroleum refinery. It is giving the fuels, solvents, bulk chemicals, plastics, fiber, fine chemicals, and oils. Now, in case of biorefinery, you are getting the same thing. This is a picture of a reactor where the yeast has been grown. Now you can have the fuel. I have described you. You can have the solvents. You can have the plastics, the bulk chemicals, fine chemicals, fibers, and oils. It is possible to produce the same thing. C1 is the seen gas. Ethanol is the C2, carbon 2. Now, if you look at the C3, it is the acetic acid, lactic acid, glycerol, propionic acid, all these are C3 component. So it is possible to have the C4, C5, C6, actually a chain of chemicals, just all are alternative or derived from the petroleum. Now, finally, I'll reach to the conclusion because of the shortage of time. I cannot go into details. We can reduce the waste. We can get the cleaner air. You can have the new agricultural markets. Obviously, the energy security, improved balance of the payments, address the global warming, address energy shortage, more flexible international relations, the benefit of developing nations. So we can have the so much advantages of the sustainability. Now this is actually our raw material which are going to be converted into or replace all the fossil fuels. Thank you very much.
Thank you so much, sir, for your contribution in the field of biotechnology, especially in the processing of bio-waste and the production of biofuels, which is an important step toward replacement of conventional petroleum products and attainment of sustainability. So your talk and your contribution is remarkable for the current scenario. Thank you so much, sir.
Thank you. Thank you very much.
Thank you, sir. So now it is my honor to present Dr. Vitendra Singh, a distinguished scientific officer F in the Department of Atomic Energy at Bhabha Atomic Research Center, Tarapur, Maharashtra. It is a matter of proud for me personally because one of my batchmates is serving one of the prestigious institute of India, that is BARC. So, regarding his profile, Dr. Gitendra joined Department of Atomic Energy, Bhabha Atomic Research Center in year 2007 after graduating from 51 batch of Park Training School, Mumbai. Dr. Singh did his post-graduation in chemistry from HP University, Shimla in 2006. Subsequently, he obtained his MTech in nuclear science and engineering and doctorate in chemical sciences from Homi Baba National Institute, Mumbai. He is presently heading Microwave Processing Lab of Fuel Fabrication Division, Baba Atomic Research Center, Tarapur. Dr. Singh has expertise in manufacturing and quality control of plutonium-based nuclear fuels. His area of research and development includes microwave processing of nuclear materials, characterization of fuel materials, material synthesis, and analytical chemistry of actinides. He has more than 80 publications to his credit in national and international symposia and peer-reviewed international journals. Dr. Singh has also undertaken Indo-US workshop training for improved nuclear materials, accounting and control. He is a member of several scientific and professional bodies and an executive committee member of Indian Association of Nuclear Chemists and Allied Scientists. He is recipient of DAE Group Achievement Award for year 2009 and 2019. He was conferred with DAE Young Applied Scientist Award for the year 2016 for his outstanding contribution in microwave processing of nuclear materials. It is very humble from his part that sir has given a suggestion yesterday that my talk is related to engineering field as well. So if possible, kindly arrange your engineering students and faculty to be there for during my talk. So I personally thank you engineering UIT for be there as a audience for this lecture. So, as we welcome Dr. Gitendra, his wealth of knowledge and experience promises to enrich our conference. We eagerly anticipate his insight and extend a warm welcome to you, sir.
So over to you, sir.
Thank you, Dr. Nisha. Uh, at the very onset, I would like to thank the organizers, Vice Chancellor FCB BSU University, Jalandhar, and especially the delegates and the audience. So, after giving this quite elaborate introduction of mine, so I would be directly coming on to the topic, an overview of applications, manufacturing techniques, and characterization of nuclear fuels. So, in fact, previous uh, speaker, Professor Jana, already has uh, talked much on the conventional fuels. Uh, so he has made uh, my work little easy. So before I go ahead, I would like to tell something. After deliberating over 2 years, 2 days, last 2 days, and discussing several and topics related to chemistry, uh, biochemistry, biofuels. So this would be, I think, a different taste for you all. And I yesterday I requested Madam, because this work is related not only to nuclear community, or not only to scientific community, to engineers also. They can also learn. They can also get more acquainted with mm, the the work what we do for uh, our country. So moving ahead, it's not working. I think, yeah, now it is working. These are the outlines of my talk. I will be going first to the introduction, empowering energy sustainability through nuclear. Then we'll try to understand the Indian three-stage nuclear power program, actually where we are. What are the fuel candidates for nuclear reactors? I'll be touching little on uranium, plutonium, and thorium. Uh, then after uh, advanced fuel designs and the rationale behind their development, the nuclear fuel fabrication, the manufacturing technologies. I am involved in plutonium-based uh, fuels, so I will be more discussing about that. Then how chemistry or metallurgy or physical sciences, they are related to the topic of uh, fuel manufacturing. Then through important advanced techniques, microwaves and laser, how they are contributing in fuel fabrication, and a little contribution towards space exploration applications that we could do, that I will be telling, and finally I will be concluding. So if you see this particular slide, this is the carbon dioxide emissions from the various uh, electricity generating sources. So if you see the carbon dioxide equivalent per kilowatt hour for uh, coal, the figure is quite high. And if you compare it with the other renewable, and particularly to nuclear energy, so this figure is very low. It's around 12 gram equivalent carbon dioxide per kilowatt hour. And this is the, sorry, this is the average life cycle carbon dioxide equivalent emissions for various electricity sources. So it may come to your mind how Solar energy is generating carbon dioxide. Let me tell you, this particular slide is showing the carbon dioxide emission in their lifetime. Everything, for example, photovoltaic cells, they must have or they have their carbon footprint somewhere, and this is the total carbon dioxide or equivalent calculation which is done for uh, entire life cycle, including the erection, transport, and while operation. Next, so nuclear power generation, if I see worldwide, so the contribution of nuclear power is highest in France. The 78% power or near to 80% power is taken from nuclear. And contrary to that, if you see the in the Indian context, we are somewhere here. So that is the big reason of worry. If you see our contribution, it is around 3% only. But you know, we are the biggest economy. Our energy requirements are quite high. So the next slide. This is nuclear power generation world at a glance. Because of this, we are somewhere here. So this is the slide showing nuclear energy generation for the year 22. So we are somewhere around 50 terawatt hours. Next. This is the total installed capacity of electricity generation in India. So as I already told, this is around, we are contributing somewhere 3%, but we have a long way to go. Besides power generation, nuclear is contributing in other fields also. So the word nuclear or atomic normally frightens us. But a very few realize that nuclear energy and related technologies have been critical tools in uplifting the life of human and their living standards. So besides power generation, nuclear is contributing in food processing, radiopharmaceuticals, nuclear batteries, radio tracer applications. It has medical applications, and nowadays also in the nuclear agriculture. Next. Yes, I would like to show, because we should know at least what are the various operating reactors in India, and I am quite sure many of us know the first uh, commercial power reactor of Asia was set up at Tarapur. So that is still operating, and then after subsequently, now we have around 23 nuclear power stations uh, operating, and these are under the construction stage. Kudankulam nuclear power plant 3, 4, 5, and 6, and similarly in Haryana also uh, two uh, two nuclear power reactors, they are under erection. Next. This is about the three-stage Indian nuclear power program. Uh, we are a lot more talking about sustainability. So uh, sustainability means continuity. So uh, because the petroleum-based fuels or the conventional sources of electricity, they will eventually end up on one day. So we have to think of some sustainable kind of thing. So nuclear, if you see, nuclear energy is a clean as well green energy source. If Thumb rule, 3 gram of uranium is equal to somewhere 30 tons of coal. This is a thumb rule. So keeping in the mind, Dr. Homi Jahangir Bhabha, he architected the nuclear power program in 3 stages. Now, if you see the resources what we have in India, we have meager resources of uranium. Of course, we have largest resources of thorium. And if you see some figures, I will be telling in my upcoming slides, the assay of uranium or the quality, I would rather say, that is poorest in India and best in Australia. So we have to think rationally while utilizing these natural resources. So in that way, in 3 stages, it was planned. In the first stage, natural uranium based nuclear reactors, they will be operated to generate, to produce, to increase the plutonium inventory. And in the second stage, this produced plutonium, this will be used in the fast breeder reactors. Fast breeder reactors are kind of reactors where we produce more plutonium rather it consumes. For example, if we use 1000 kg of plutonium, we will be generating around 2000 kgs of plutonium out of that. And in the third stage, thorium will be utilized, and we are the largest, we have abundant sources of thorium, and for many centuries this plan can cater the energy requirements of this country. Next. So we have chosen a nuclear fuel cycle which is of closed kind. I will tell you, when a nuclear fuel is, I mean, simply say, burnt in a nuclear reactor, spent nuclear fuel is generated. And we, maybe this audience may not be knowing, this spent fuel cannot be as such thrown into the environment. It needs some specialized treatments or some uh, interim storage or storage in special kind of facilities. So if you see USA has chosen a open fuel cycle. They are not going for closed fuel cycle option. And Canada kind of thing, Canada kind of countries, they are still opting the option of wait and watch. They are running their nuclear reactors and just storing their uh, spent nuclear fuel. And particularly India, we are the country, and Japan, Russia, we are reprocessing it. So reprocessing of nuclear fuel, we get lot of uh, important thing out of this. I'll tell you, spent nuclear fuel, it gives you plutonium, which is very, very important for uh, energy program and for other strategic programs of India, and other medically important isotopes. Nowadays, people are talking more on uh, applications of nuclear in pharmaceutical, nuclear medicine. So all those things we are getting from spent nuclear fuel. Next. So this is a very basic slide, nuclear fission. This we already we must have studied somewhere in 6th, 7th, 8th, 9th, 10th up to these classes. So uh, this is about that only. The important is here. These are the candidates for nuclear reactors: uranium, plutonium, and thorium. And uranium is known as the mother element for nuclear industry. I will tell you, thorium as such is not fissile material. It is actually a fertile. It need to be added with some fissile materials, for example, uranium-233 or plutonium-239. Then and only this can be utilized in nuclear reactors. But of course, it is a fertile. Fertile means it can produce something which is fissile, which is important for nuclear program. Next. Next. This slide is maybe particularly interesting for the students. What is uranium? What are its properties? Naturally, uranium is naturally available. After uranium, everything is man-made. So this is the naturally occurring uranium. It contains three chief isotopes: uranium-238, uranium-234, and uranium-235. The percentage of uranium-235 is around 0.72% only. And because of this 0.71% is responsible for power generation or some nuclear weapon program. So this I would like to show here. Total uranium resources in India, it is around 50,438 tons of U3 which would give a metal of around 2 lakh 97,000 around. It is, I think this is not complete. The figure is different. It's not coming. So this exploration of the uh, various ores related to uranium, it is being done by Atomic Minerals Directorate, which is part of Department of Atomic Energy. The processing or preparation of uranium, it is done by Uranium Corporation of India Limited, which is a PSU in Department of Atomic Energy. Next slide, please. Plutonium. Regarding plutonium, yes, it is man-made, and when the name plutonium comes, we little think about it. Nearly 16 isotopes of plutonium are known so far. The important one is plutonium-239. This is highly radiotoxic. It is highly hazardous material. Depending upon the composition, isotopic composition of plutonium-239, it is graded as power reactor grade or a weapon grade. So it is very, very important, and it is very, very critical to handle, especially plutonium. And plutonium-238 is a isotope which has find some other applications. Plutonium-238 is used in heart pacemakers. It is used in radioisotope heating units, which is required for exploration of the space. Next. So this is a schematic of production of various isotopes of plutonium. Next slide. Now coming to thorium. Thorium is monoisotopic. It has only one isotope, thorium-232, and the ore from which it is extracted, it is obtained is monazite, and we are rich in monazite. Kerala, Karnataka, the beach sand of Kerala, Karnataka, Tamil Nadu, Odisha, this is quite rich in monazite sand, and because of the higher content of thorium in those sands, the radiation levels in the beach areas, it is quite high. It is 10 times higher than what we have here. Next. So these are the fuel fabrication facilities in India. Atomic Fuels Division, BRC Mumbai, Nuclear Fuel Complex, which serves the commercial reactors of India in Hyderabad, the Radiometallurgy Division in Mumbai, Advanced Fuel Fabrication Facility, BRC Tarapur, where I am working. These are the upcoming facilities which are coming now. Next. So, nuclear fuel, what should be the qualities of a nuclear fuel? How it should behave? What should be its qualities? So, first of all, it should have, it should be quite stable. It should have stable physical and chemical stability during in reactor operation, because during reactor operation the temperature of the fuel can see the temperature of around 1700 degrees centigrade or 1800 degrees centigrade. So it should sustain that temperature. Now it should be reprocessable. Coming to back slide, it should be reprocessable. The fuel should be homogeneous, should not have agglomerates of some fissile, because the temperature, otherwise there would be temperature inhomogeneity, and it should of course the ease of fabricability. Next. Radiological and other issues related to handling of uranium, plutonium, and thorium. These are, of course, very, very specialized containments are required for handling them. Uranium, because it is naturally occurring, so it is least easy. I would say it is most easiest to handle. But when we go to man-made plutonium or americium, these are really challenging, and one has to think. So for uranium, what we need is a graded ventilation only. It can be handled in open places. Plutonium, it needs graded ventilation and alpha leak tight glove boxes. Then if somebody is working in biological or this kind of sciences, he may be knowing about the glove boxes. So it has to be handled. Plutonium also has to be handled inside glove boxes. It cannot be handled outside. Uranium 233, yes, it need graded ventilation, shielded glove boxes. Glove boxes are shielded because the radiation doses are very, very high. We cannot even stand for 5 minutes or 3-4 minutes. So this is about the handling. This slide is cutting. So go to next slide. So these are the fuels used in Indian research reactors. The first research reactor is Apsara, which somewhere I have shown you the date. We are first nuclear reactor in Asia, 20th January 1957. It is in VRC. The name is Apsara. In 2009, it stopped working. Then we have taken it up for revamping. And after revamping, it started in 2018. And the name now is not Apsara, it is Apsara U, Apsara Upgraded. So these are the fuels which are used in this reactor. Uranium aluminide first. Now it is uranium silicide, because this, if you see this uranium aluminide, it is having uranium 235 composition more than 93%. Weapon grade uranium was being used in this. So because we do not have these kind of facilities, so as a part of Atmanirbhar Bharat, so we switched over to a lesser composition. Now uranium 235 is lesser than 20%, and of course there are lesser concern with the with the safeguard of these, and that is why we have chosen this one. Then Cyrus, Dhruva, these are the reactors which use natural uranium as metal, and this is the FBTR, a reactor which is first of its kind in the world. This is the only reactor which runs on carbide based fuel. Next. So these are the photographs I would like to show to this audience. This is the kind of fuel it is being used in Indian nuclear reactors. This first one is BWR, boiling water reactor, then PHWRs, then this is the prototype fast breeder reactor, and this is Voda energy reactor, which is working at Tamil Nadu. Next. This is the first commercial reactor I was telling you. We have contributed a lot towards this. We are making its fuel. The fuel requirements are very, very high. You can see the first core requirement is around 40,000 fuel pins, and 40,000 fuel pins, if you say it require a handling of nearly more than 4 tons of plutonium. Or if anybody has heard about criticality accidents regarding plutonium, yes, nuclear criticality accidents are very, very severe kind of accidents. And what is a nuclear bomb, that I need not to tell on this kind of platform. So you may find the details. So it is very difficult to work with this kind of material. Now, next slide, please. These are the some advanced fuels, conventional fuels we have discussed. We are working with natural uranium dioxide, then we have used uranium plutonium oxide, then thorium dioxide. These are the advanced fuel designs where some non-oxide fuels, they are being now developed, or they are now being explored. Mixed carbide fuel, mixed nitride fuel, then metallic fuels, then cermet. Cermet is a term where ceramics are put in metallic matrix. Metals has the property of good thermal conductivity, and ceramics, they have more stability at higher temperature. So cermets, it is in between them, and where the temperatures, the working temperatures can be improved and stability can also be improved. Then last one is the triso fuel. This is triisotropic fuel, where fuel kernel is coated with a number of layers using pyrolytic carbon, silicon carbide kind of thing, using chemical vapor deposition techniques. So these are the fuels which are called accident tolerant fuel. If some kind of accident also occurs, they can contain the fission products inside them, and public has need not to worry. Next. Now coming to fuel fabrication processes, how nuclear fuel is fabricated, what are the raw materials? Raw materials are, I am telling you, is a naturally occurring uranium dioxide, which is the mother element for nuclear industry. And uh, the responsibility is taken by Uranium Corporation of India Limited, which prepares magnesium diurenate or yellow cake. And this yellow cake is transported to nuclear fuel complex Hyderabad, and these are the process steps which involve a lot of chemical processing, and finally we get centrifugal grade of uranium dioxide. Next. Whereas ammonium diurenate process is followed for precipitation or separation of uranium dioxide. Oxalate precipitation, it is followed for plutonium or thoria preparation, and these are the steps uh, given for the process. Next. Uranium dioxide fuel fabrication for PHWRs, it is by NFC Hyderabad. It is manufactured from natural uranium dioxide, and I will tell you, uh, uh, natural uranium dioxide, it is available in India, but we are also importing from other countries like Kazakhstan, Australia. They are the biggest exporter for us. Import. We are they are biggest exporters of natural uranium dioxide. So going to next slide one. Now coming to plutonium-based fuel. Next. Plutonium, I was telling you, this is handled in special enclosures called glove box. Entire work is carried out inside these kind of glove boxes, and even a single particle should not come out of the glove box into the working environment, because it is otherwise a radiotoxic, highly radiotoxic materials, and may affect the uh, uh, personal health. So this is the mm, kind of laboratory we are working, and there is a instrument called plutonium in air monitor, and this is called a sieving kind of device. This at a time 24/7 monitors the concentration of plutonium into the environment. So the moment it exceeds those levels, we stop work. That it comes down, we have to work there. Next. So this is the flow sheet of uranium plutonium mixed oxide fuel fabrication, where uranium dioxide, plutonium dioxide, they are mixed together in a attrator. This is a machine called attrator. They are mixed together, milled together, and then this is followed by numerous unit operations, followed by pre-compaction, final compaction, then sintering. Sintering is a process of heating at a very high temperature to get the high density. So likewise I would like to tell the example of जैसे हम लोग ईंट बनाते हैं ना, sintering is that process, heating or firing at a very high temperature with the high density as well as the strength. So that kind of process, because uranium dioxide and plutonium dioxide, they are refractories. We cannot otherwise get a high density there. So then this is the photograph of the fuel pellets, uranium plutonium dioxide fuel pellets. These are loaded into the each fuel pin. Then these fuel pins are welded, decontaminated, and finally sent to the destination for working as a nuclear fuel in the reactor. Next. So this is a compaction uh, process which is showing the process of fabrication of fuel pellets. The powder is fed on this side. This is the mixed powder, and this is a rotary compaction press, and pellets are ejected over here. These are green pellets. Now they are further subject for sintering. Next, next. And this is a photograph of a sintering furnace. The quantity is around 20 kg. It is sintered at a time. And process of sintering, I have shown you green compacts, they look like this. And after sintering, there is shrinkage in the dimensions. Please let me tell you time is there, madam, Nisha madam, time is there. Okay. So temperatures are 1650 to 1700 degrees centigrade. Of course, it is not done in air atmosphere. It need different atmosphere, nitrogen plus 7% hydrogen. Thermocouples are different because measurement of temperature is very, very crucial when we do this kind of thing, because tolerances on the dimensions are very, very tight. So these kind of thermocouples we use multi thermocouples, type D thermocouples, tungsten 25% rhenium and tungsten 3.5% rhenium. Next slide. This is the process of stack making for fuel loading. I was just telling these are the fuel pellets which are loaded into the fuel pins, and then fuel pin is welded. Next slide. These are the welding stations. After inserting the fuel pins, on the one end, the other end of the fuel element, it is welded using techniques like pulsed tungsten inert gas welding or pulsed ND arc laser welding. Next. After manufacturing fuel or the fuel elements, it has to undergo the characterization. So the first and foremost requirement is the integrity of the weld, which is ascertained using X-ray radiographic technique. Next one. And this slide is showing the loading of the fuel elements in magazines, and then this kind of magazines, fuel magazines, they are transported to the reactor site. Next one. Now coming to characterization, the raw materials are characterized. These are the powder properties. The raw material, uranium dioxide, plutonium dioxide, thorium dioxide, they are characterized for various number of parameters. We see the particle size, distribution, BT specific surface area, bulk density, apparent density, oxygen to metal mole ratio using a number of chemical techniques. We need to have it need to meet the total impurity content. If you see the impurity content, it is very, very stringent to meet the nuclear requirements. Next one. This is again the powder characterization work related to these only. These are the showing the BT specific surface area graphs for plutonium dioxide. The specific surface area is around 16.24 meter square per gram. That is for thoria, and this is for natural uranium dioxide, and this is showing the particle size distribution. of natural uranium dioxide. Next one. As I was telling you, there are two oxides which are mixed together, plutonium dioxide and uranium dioxide. The plutonium has to be homogeneously mixed with the uh, uranium dioxide. That homogeneity is ascertained uh, using a technique called alpha autoradiography, because we know plutonium and uranium, they emit alpha particles. So based on that, this technique, this is ascertained, and you can see this is a fissile. Here the homogeneity is quite good. Here you can find a non-uniform distribution of plutonium in MOX. These are rejected in the quality control. Next one. These are the chemical characterization techniques which are used for uh, controlling the controlling the quality of the fuel. We estimate the uh, heavy metal, uranium, plutonium, and thorium using various destructive and non-destructive techniques. In the destructive techniques are conventional techniques like potentiometric titration kind. They are still serving. People are now moving towards non-destructive assay, but I will tell you the conventional chemistry that is considered the best one. If a technique has to be established, it has to be established against the basic, that is the potentiometric titration. So those are still working as a reference standard for us. And though we have now developed some non-destructive techniques like neutron well coincidence counting or wavelength dispersive X-ray fluorescence based methods, then stoichiometry thermogravity method based on gas equilibrium. Number of non-metallics are also determined, carbon, nitrogen, hydrogen, they are determined in the fuel by using various techniques. Uh, Next type. Now solid solution formation, this is ascertained using XRD and using a dissolution test. So this is quite important from reprocessability point of view, because ultimately the fuel has to be reprocessed. I mean, spent fuel has to be dissolved and the valuables has to be recovered from that. So that point of view, solid solution formation test is important to be conducted. Next. So lasers and microwave, I'm sure that many of the industrial applications they are accepting now. Uh, they are uh, they are now mm, they are now going for these kind of adapt these kind of techniques, because they offer distinct advantages over the conventional techniques. So uh, in the nuclear fuel cycle, particularly to nuclear fuel fabrication, microwaves and lasers, they are now being extensively used. If I say microwaves are used for denitration or co-denitration of uranium, plutonium, thorium nitrates, recycling of rejected fuel, processing of intermediates to carry out oxidation reduction calcination, waste remediation. And microwaves, I was somewhere studying, it is now being used in hygienization of municipal waste kind of thing. So microwave sintering, this is the latest work we have carried out. Laser welding of end plugs, as I have already shown you. Laser decontamination of the fuel pins and laser marking of the fuel elements. Next one. So we are fortunate that uranium dioxide is a very good absorber of microwave. I'll tell you, uh, every materials cannot be heated in microwave. If you put a glass, it cannot be heated. If you put a silicon carbide, yes, you can get the temperature of 1700, 1800 degrees centigrade. And in case of uranium dioxide, we can go up to 2600 degrees centigrade. So we are fortunate in that regard. The important nuclear materials, they are microwave active. Next one. See, the microwaves, what we use in the household applications, they are somewhat different, but the principle wise they remain same. However, in our applications, for industrial applications, this has to be first of all a commercial kind of thing, and they have to be adapted inside this kind of enclosures called glove box. So next one. So this is the a small contribution that we could do towards uh, recycling of the rejected fuel. For any industry, if you prepare, for example, bulb industry, if you prepare 1,000 bulbs or 10,000 bulbs, it is almost impossible. I would say it is not possible to get all acceptance of 100%. There is always some rejection. So while manufacturing fuel, there is a rejection of fuel always. This has to be recycled. So that is a contribution that we could do using microwave. We have developed a technique called microwave denitration technique to recycle those materials. We can, because these cannot just be thrown into the environment. We have to think about them. Next one. This is another technique which is not a wet technique, rather a dry processing technique. Next one. Microwave reduction and oxidation using microwave processing. Next one. The microwave reduction carried out at 550 degrees centigrade for uranium, plutonium oxides. Next one. This is a parameter optimization study for microwave reduction. Next. Next. Small work now we have initiated moisture removal and calcination of plutonium dioxide powder. Uh, we have got quite encouraging results. Probably we will be publishing this work also, and it has been found quite effective to remove the moisture right from the core of the materials, and to remove carbon from the core of the plutonium dioxide, because the plutonium dioxide always is associated with oxalitic carbon, and this is a culprit which need to be completely rid of from the material. Next one. Recovery of plutonium from used graphite crucibles. Next. This is the alpha waste incineration work using microwaves only. Next. Sample digestion. This particularly universities or school institutes or any normal laboratories, they are going for this digestion, acid digestion of the samples, many biological samples or maybe some mineral kind of samples. People are now going for microwave digestion because this is quite quick. At the same time, there is no loss of constituents, and I will tell you, we also have introduced this for dissolution of these refractory oxides, and these are pressure vessels. The pressure is around 6 to 7 bar, and the times what we could save is around 1 by 10. So uh, this kind of advantage we are getting from microwaves. Next one. This is a very quite recent work, centering of uranium dioxide using microwave, and this we published in Ceramics International in last year only. And I'll tell you here something. This centering can be done in two modes. One is direct mode and one is hybrid mode. So we could first time establish direct mode centering of microwave. Next one. Next. Next one. This we have discussed. This is a laser decontamination of fuel elements. Next one. Laser marking of fuel elements. This we may have come across several times in the market. We go there and we go for laser marking of our nameplates. So that this is a work that we have introduced in our industry also. And next one. Here I would like to tell, here we have recently made a contribution. This is a cutting from Hindustan Times recently. So there was a statement by Director ISRO. Can you read it? I'm unable to read it. So this is the work we have, we could do from BRC. You know, Chandrayaan 3 last year we have sent successfully. So the Chandrayaan 3, it is having RHU units, radioisotope heating units, or we say it is a nuclear battery. So that contribution is from BARC, and we could do it. And the material what was used, I was a part of that team. We could make it. The RHU is made using americium dioxide. So it is working there. Next one. And this is a again related to this work only. Uh, Fabrication of porous platinum vent frites for radioisotope power sources. This we could publish recently in Nuclear Technology. Next one. These are the related data, the helium flow rate in the low pressure segment, electron micrograph of sintered platinum 10% rhodium discs. Next one. So this was just a flavor of the activities what we do in BARC. It is I think it is only what I could show is only 10% or 5% of that only. It is it is my actually now let me summarize first. Nuclear is the clean and green source of energy and is the way forward towards the long-term energy security of the country. Besides power generation, nuclear is contributing in several other spheres of society like medical, food processing industry, and other industries. Nuclear fuel is the heart of nuclear energy program. Without this, we cannot run this show. Operation of nuclear reactors and handling of radioactive sources is carried out with highest standards of safety and security. Nuclear fuels undergo stringent quality control checks, and just I have shown you advanced technologies like microwave processing, laser processing. They are progressively gaining more and more attention of nuclear community for variety of applications. Next one. Oh, so that comes to an end, and let me thank the organizers, Vice Chancellor, SVBSU organizers, and Dr. Nisha Sharma, and other Dr. Yunis. I do not know the names exactly. Uh, so for inviting me and deliver this flavor to this audience. And I would be more than happy if you ask few one or two questions, because in the entire 2 or 3 days program, I have not seen even a single question from the audience. I will take your questions, sir. And particularly for the students of universities or college going, they should interact this kind of conferences because they are rarely conducted. They should interact more and more and get information. So that is all from my side. I can take question from sir, please. Mic is there. Okay. सर आप बैठ के पूछिए, बैठ के पूछिए. Yeah. Right. Right. Let अच्छा हाँ.
एक खाना चाहते हैं, एक एग्जांपल इनको बताइए, we are today जो when it comes to we are an agriculture production state, और वहाँ एप्लीकेशन क्या होती है
मालूम है, राइट राइट।
इंफॉर्मेशन सारी अवेलेबल है गूगल,
यस
कि उसकी एप्लीकेशन कैसे करनी है, मोड एंड मैकेनिज्म क्या होगा, वेरी थ्योरेटिकल।
करेक्ट।
हमारी मानसिकता ऐसे हो गई है कि भाई पेट पे खाना हो, खा के भी लोगों को खिलाना पड़ेगा।
So I
Sorry,
no, I appreciate, sir. And let me come to the response to your question, sir. So that is why I have openly invited a question from the audience. So मैं जस्ट बता देता हूँ कि न्यूक्लियर एनर्जी और इसको लेकर ना बहुत सारी भ्रांतियां हैं। I am working there since last 17 years. I am also from this session only, right? So मैंने देखा है, if you see my the conclusion slide, the nuclear materials, they are handled in such a way with the highest priority given to public safety and security. Now coming to your first questions regarding microwaves, I will tell you microwave is not a nuclear radiation, and in most of our kitchens microwave is now a device. हम लोग खाना उसमें बनाते हैं, हम लोग reheating उसमें, mostly for reheating purpose it is. See, microwave, if I say, I would straightway say using a microwave is always safe, but handling it wrongly, this can cause concerns. Likewise, I will tell you, there are a number of interlocks given on the microwave cavity. If door is open, microwave cannot be started. Microwave is not a nuclear energy, I already told you. Fine. Now, coming to applications, I have taken a few examples. It is nowadays a essential part of a general laboratory. General laboratory means where samples are prepared, samples are digested. People use microwaves. There is no public health concern related to microwave. Microwaves, if has it been the case, ये market में available ही नहीं होता. There is no concerns about you can eat microwave heated food. There is nothing to worry about it. Now the next question, can you repeat that question? Actually, I forgot. Yeah, yeah, yeah. Right, 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 right. Correct. Yeah. Right, right, right. So I will tell you the applications of radiations in the processing of food. So you may be knowing any kind of food, or for example, I am taking the example of onion, or some fruit like kiwi, lychee kind of thing, which has certain shelf life. To extend the shelf life, BRC has set up a food processing irradiator, a number of food processing irradiators at various locations in the country. Now the irradiated food, it has longer life. It can be exported to other countries, and I'll tell you further to this one, other countries, they are accepting Indian onion then only if it is irradiated. So these are the contributions in the area of food processing. Coming to nuclear medicine, I would say a simple thing about radiations. People are knowing that radiation is a source of cancer. This is a general thing which we have in the mind. I will tell you, cancer can be cured using radiations only. Cobalt 60 is the source. Radiotherapy is the chemotherapy, or radiotherapy is the solution. Babatron is the name of the machine. You can search, you can Google on that. So, a number of numerous uh, tumor kind of things that has been done. Fantastic work has been done in the area of radiopharmaceuticals as well as the radiation therapy. So I think I am taking the time of next lecture. They are ready. We can discuss during the lunch hours also. Right? Thank you very much.
Thank you so much, sir, for your valuable talk. And sir has highlighted on various aspects of nuclear fuels. And we came to know that India is a rich source of thorium, but the quality wise, that is not that much accurate as available in Australia. And the main highlights of Sir talk is regarding nuclear fuel, but the primary requisite properties that fuel must have, and the various nuclear reactors which India has developed since 1957, like Apsara upgraded, FBTR. Then Sir has highlighted certain advanced advanced fuels, especially accident tolerant fuels, which are very important for the nuclear operations. And then Sir has highlighted on various fuel fabrication techniques, methods, and characterization techniques, and also stressed that our primary and techniques of chemistry, that is potentiometric and thermogravimetric techniques, they are still used during nuclear fuel characterization. And at the end, Sir has given certain highlights over recycling of rejected fuel, which is a very main crucial point at this stage and quite relevant for our talk, for our conference themes, because we are all finding the solutions that how the sustainability could be achieved. Then Sir has also highlighted certain points regarding laser markers, radioisotopic materials, nuclear fuels, and at the last, we should be not worried about the word nuclear, because nuclear fuel is the green fuel. The only condition is how to handle that. That is the primary concern. And if our handling for that material is accurate, if we follow the protocols accurately, then that is the safest one for the future techniques. So thank you so much, sir, for your valuable words, and for these inspirational lecture. And apart from that, during the question answer session, as Professor Chima has mentioned, two concerns. So, Sir has also addressed those very beautifully, and we must also find the answer that we should not go for that. uh, क्योंकि बहुत सारे लोगों को यही लगता है कि माइक्रोवेव का बना हुआ खाना है, बहुत सेफ नहीं है, ठीक नहीं है, बट इट इज द सेफेस्ट वन. So thank you once again, sir, and you have spared valuable time, and you have accepted our invitation and came far away for this conference. So we are blessed with your presence. Thank you, sir.
Thank you, Dr. Nisha. I am highly grateful to worthy society member Sardar Joginder Singh ji, who has graced this occasion with us. We welcome you, sir. Moving on further to our technical schedule, may I have the privilege to invite our next resource person on stage, Dr. Onkar Singh Brach. Sir, Dr. Onkar Singh Brach is an associate professor in the Department of Zoology and Environmental. In addition, Sir has also been nominated as resource person under the National Environment Awareness Campaign by the Ministry of Environment and Forests, Government of India by Punjab State Council for Science and Technology. In addition, he holds membership of various professional bodies, organizations. He has been reviewer of journals such as Journal Secretary Punjab.
About my paper, that is role of computer science in sustainable development. These are the table of content of my topic. Firstly, sustainable development. It refers to the development of present world without compromising the ability of future generations to meet their own needs, or we can say that it is a better way of doing development both for the future and the prevailing. Next is computer science and sustainability. It serves as a catalyst for positive change by providing the theoretical foundations for data-driven decision-making, environmental monitoring, and renewable energy optimization. The underpinnings of computer science are fundamental in shaping strategies and other approaches that promote sustainability.
Very thankful again. So today I'm talking about impact of climate change on biodiversity. So in the first instance, I would like to say that scientists says that if we will lose one species, one organism, that can lead to the loss of another 20 more species because each and every species they depended on each other. So if we are losing one, we are losing 20 more species. And unfortunately, by unawareness, we people losing 50 species per day. 50 species per day. And now we can multiply 50 with 20. So unknowingly, with the, we can say, with the advent of so many disasters, that is loss of habitat, forest fire, pollution, so and so, climate change, global warming. So we are losing 1,000 species unknowingly per day all over the globe due to the various anthropogenic activities. So please, next slide. So so habitat, we can say that is highest temperature have a force animals and plants to move higher elevations. So this is a very, very, by the way, unique phenomenon nowadays because of, we can say that is from lower sides, we are losing the coldest areas in upper areas, and from the lower areas, birds are moving towards, birds and other animals are moving toward higher areas. So it is already said that so sparrows from Punjab they're moving upwards because climate here in Punjab that is not conducive for sparrows here to live. That's why they are moving upwards. That's why the wild organism, other wild organism, they're also moving upward. So this is how. So that's why plants, animals resulting in first climate-driven species. That is, we can say, extinctions with with every degree of warming. So if warming is there, then we are losing so many organisms on this earth. So animal and plants, they are, there is shift of reproduction. So now if we say the temperature is rising, if we take one example of golden mahashir, so that can breed up to 28 degrees C of temperature. So if temperature of the water is rising, then what happens? The breeding activities of those particular fish that is being, we can say that is hampering. So that's why we can say if if the fish will not lay eggs without of not the conducive environment there, then how we can have next progeny of that particular fish? So this is how fishes and other organisms on this earth are they are vanishing like anything. Then length of season are growing season. Length we can say nowadays. So due to the climatic actions or we can say global warming, the seasons are shifting. So with the advent of those particular things, things are very precarious, or we can say things are very horrendous. That growing seasons are altering. That's why with the resultantly organisms are vanishing from this earth. Then population size is reduced drastically. So if population size is reduced drastically, then we can say that the fate of organisms present on this earth it is very very bleak. So you can say pest and disease outbreaks. With the advent of high temperature, the fungal diseases are erupting. The pests are increasing. That's why we can say the biodiversity is losing very very fast pace nowadays. Next, please. So if we say that according to the rise of temperature on this earth, what happens there is the mammals losing half their habitat if temperature will rise 1.5 degrees C. So we can say half of. So then 8% of mammals so losing half their habitat if temperature will rise to 2 degrees C. Then 41% of mammals are losing their habitat if temperature will rise 3 degrees C. So this is the fate of the organisms if temperature will rise unabatedly with unawareness of we people that we people are contributing to the rise of temperature by contributing pollution to the environment. So that's why the organisms are losing will be very fast pace. Now number two, changing life cycle of the organisms. So shifting flowering time is a very problematic these days. So if some of the organisms they feed on flowering time, some of the organisms feed on fruiting times. So if that will shift, the organism which are dependent on those flowering and fruiting, they will lose their life. So this is how if flowering time do not overlap, pollinator will be less successful and producing less fruits. So if flowering time will be changed, the pollinators they will also change their habitat and then we will lose those fruits and we will lose those organisms from this earth. Bee and bud pollinators must also adjust their activity in sync with changes to flowering time to facilitate, but it is not possible. The other organisms they cannot sync their lifestyle with the appearance of other things. So this is how things are going on. Next, please. So birds migrating pattern changes. So we people are experiencing in Punjab as well, right from we can say last 1 decade. So bird which are migrating towards India, they are losing their sheen. So number of migratory birds are decreasing day by day. Next, please. Next slide, please. So this is a story about Siberian crane. Siberian crane is a very beautiful bird. It comes from Siberia to various parts of the world. It visited last in India at Bhaktapur century in 2001 2002 winter. But after that it has not visited. So this is how the pattern of migratory birds is also by the way we can say declining very with a fast pace. Next, please. So I would like to tell a story of this painted stock. Painted stock so many years back, 1981, Salim Ali reported 10,000 birds of painted stock at Bhattapur Century. But now, not even a single bird arrived in the Bhattapur Century. So this is the fate of migratory birds. Those are reaching to our wetlands due to the climatic changes. Next, please. So this is the whole story about we can say that is painted stock. Next, please. So this is how we would like to say here the story of migratory birds those are occurring at Harike wetland. So we have reported in 2016 1,06,000 birds at Harike, and now in 2024 we have received now 40 to 50,000 birds only. So this is how birds are declining day by day due to the shortage of wetland wetland areas reclaimed by the very, very fast pace. So food availability is also less. So and the cover area is also less because of the growth of water hyacinth on the Ariki wetland. So this is how you can see here the birds are declined, arrival of birds is declined very, very drastically. Next, please. So now the same way with the amphibians. Amphibian crossing, amphibians are used to lay eggs. All the amphibians, all the frogs, they used to lay eggs in the same season. But due to the shifting of the season, these are not, by the way, used to lay eggs in the same season, and that's why their population declining all over the globe. So many species of the amphibians and the fishes and birds we are losing very, very, very fast pace. Next, please. So we have done an experiment on the frogs, okay, how they behave to the climate change, or we can say temperature. We have given a sheet to the hatching eggs of the different frogs. When we will cover by the sheet when the UV rays, the eggs are showing excellent growth and activity. If we lose, if we will keep those eggs without any sheet, the growth of those eggs and hatching of those eggs has hampered. So hence now that climate change has and global warming has great impact on the growth and the hatching of those frogs. That's why the population of frogs is declining day by day. Next, please. So the same way you can say the butterflies, their pattern of larva pupa hatching that has shifted drastically. That's why the population of these beautiful insect is also declining day by day, and their pollinating activity that will also happen in future if they are being lost with the same pace. Thank you. Next, please. So I already told the we can say that tree line is moving upward. Tree lines. So with the advent of we can say melting of ice from the high hills. So and with the global warming, the tree lines are going upward, and this is how. And the time is not we can say far away when the snow will melt and the whole that particular snow clad areas will covered with the vegetation. So next please. So this is how ecological effects. Ecological effects are there. We can say that is if we talk about sparrow. So sparrows are by the way declining in Punjab due to the loss of habitat. Habitat is being lost, and with the advent of pollution, what happened there is the infestation of heavy metals into their eggs that is causing the early we can say that is breakage of eggshell of the sparrows and other organisms. That's why the population declining day by day. Spread of disease with the high temperature, the we can invite the fungal diseases into the various organisms. That's why over so many species are declining. If we talk about, we can say that is fishes, they are declining with the disease erupting that is fungal diseases to those organisms. Next, please. So this is how loss of livelihood of the locals. So with the advent of we can say that is loss of biodiversity, the locals can also lose their livelihoods as with the we can say that is global warming. What happened there is a less we can say production of forest resources and other wildlife organisms. Effects of food production. So this is very, very, by the way, important. The loss of biodiversity can have vast adverse effects on food production. Since we cannot can nowadays exploit many natural living spaces to the unhealthy degree changes that we many food sources which are being lost these days. That is why the production of the various crops is declining with a very, very fast pace. That's why the food is declining. So next we can climatic changes, so that is extinctions. In the recent times, we have the so many organisms, that is mammals, birds, and we can say that is they have gone into oblivion. In recently golden toad that has been extincted in 2019 from the Costa Rica. So this is how beautiful organism, beautiful mammals, beautiful amphibians, birds we people are losing. Next, please. So this is how amphibians, so mountain mist frog have lost, we have lost, that has extinct from this earth in 2021. Again, we can see that is a Pinta giant tortoise. That is also, this one is also gone into oblivion from this earth with the advent of global warming and climate change. Next, please. So this is how sharp is noted, that is day frog. This is also we can beautiful organism that has lost from this earth, and Polly's bird that is extincted from this earth in 2019. So this is how we are losing our important flora and fauna from this earth. Next, please. So this is again, you can see here, this is white eye, and then Collis Aquila. These are the beautiful birds. They have gone into oblivion recently in 2016, and the if the climate change will go like this, or we can say with the same pace, we will lose, the day is not far away when we will lose other flora and fauna from this earth, and this can these kind of activities can cause havoc on this earth. Next, please. So threat with extinction, this is how plants are reducing by 40%, amphibians 35% threat is there, corals 30%, mammals 22%, then reptiles 18%, fishes 14%, so birds 13%. So this is the scenario that we are losing our biodiversity from this earth. So this is how, if climate change will not be stopped at right now by adopting so many remedial measures, then day is not far away when we will lose all these beautiful organisms. So if we talk about corals, next please. So coral we are losing. So this is a normal picture of the corals present in the sea. Next, please. So if the temperature will rise 1.5 degrees C, so the population of coral will reduce. So this is one patch that will that will be left after that with the 1.5-degree temperature. Next, please. So 90% of coral will be vanished with the rise of 1.5. Please backward slide back. So when it will rise 2 degrees C, what will happen? All the coral reefs will be vanished from the sea. Next, please. So we have hot spots in India. So Western Ghat. So this is a whole stretch. Western Ghat is there. So it sports valuable biodiversity. We can say that mammal, reptile, birds, and Western Ghats can sport 25% of biodiversity all over the India. Next, please. The same way we people are having Himalayas. This is also one of the biodiversity hotspot, and it includes 10,000 species of plants, and out of which 3160 are endemic to this range. 3160 endemic means they are not being found anywhere else, only in the Himalayas. Next, please. So this is again Indo-Burma region. This is also very important, by the way, a hotspot. Next, please. Next, please. So this is a Sundaland. Sundaland occupies 25,000 species of vascular plants, 15,000, 60% of which are found here now. So rest are depleted. Next, please. So this is how biodiversity and mitigation. We people have to go for biodiversity mitigation by adopting so many remedial measures. So if the pace of the climate change or global warming will be like it is now occurring nowadays, the day is not far away. We will lose our beautiful organism, beautiful flora and fauna from this earth. Next, please. Next. So biodiversity and adaptations. So I would like to give the example of one of the example of the, we can say, that is adaptations. So if we talk about sparrows are adapted to a different kind of habitat. Earlier they used to live in the where the humans used to live. Now they are living in services. They are living in some plants. They are living in some holes outside the households. So this is how they're adapting and adapting different kind of habitat. Uh, uh, that's why they're appearing nowadays. Next, please. So why this kind of activity that matters? This is extinction. So because it can degrade the soil as well. So if biodiversity will be there, that can help maintain soil fertility, deliver clean water to streams and rivers. If the flora and fauna will be there, recycle nutrients, then pollinate plants and including cropping plants, buffer against pests and diseases. So this is how we can find solace from biodiversity will be there. Otherwise, it can create havoc on this earth. Next, please. So status of fish diversity at Harike wetland. Next, please. Actually, we people have reported 69 fish species from Harike wetland, out of which some of fishes fall under critically endangered species, some are fall under endangered category, some fall under vulnerable category, some low risk near threatened, and some are LRLC. So this is how almost we can say 70% fish species comes under red list of IUCN, and the day is not far away when these species which comes under red list of IUCN, they will slip into extinction. So this is a big threat to the next, please. So under CR, two species. Next, please. Under category endangered, six species comes under this category. Next, please. 13 species comes under vulnerable category. So vulnerable is that 50% population already gone into oblivion. Then next, please. Then this is low risk near threatened, low risk least concern, five species. Next, please. This is a low risk near threatened. 30% population of fishes has already gone into oblivion. 70% is there, and day is not far away when this list of species will slip into uh, upper categories. Next, please. So these are the commercially important fishes present in the Hariki wetland. Next, please. So this is a Bagarius, which is a very beautiful catfish present in Harike Roped wetland. Next, please. So this is again Cyprian Scarpio. Next, please. So this is a Channa Marulius, which is present in both the all the wetlands of Punjab. Notopterus, beautiful fish species are there. Next, please. So this is again a fish species, Notopterus chitala. Next, please. Catala. So beautiful fish species are there, which are nowadays highly prevalent. But I am again reiterating that day is not far away when we will lose all these beautiful fish species. So hence Bigla. Next, please. So these are the beautiful again some minnows, small fishes. Next, please. So minnows are there, ornamental fishes present in the waters of Punjab. Next, please. So again, small fishes present in the waters of Punjab. Next, please. Again, you can say snake-like fishes. These fishes are very specialized. They have accessory respiratory organs present in them. They can survive in air as well. They have lung-like features in their body. Next, please. So Rita again, catfish is there. Next, please. Next, again, Speta Singhada. This is a we can say known as Singhada fish species in Punjab. Next, Vlago. Next, please. So this is, by the way, last topic I would like to cover. This is a golden marsh here, and it used to live in a cold water up to 28 degrees C. And if we can raise the temperature, growth will be reduced. Next, please. So now you can see here at high temperature growth has reduced, at low temperature growth uh, is by the way intact. So this is experimentally proven in our laboratory. If we will keep these species into high temperature, the growth will be reduced. So if it will happen in the nature, what will happen? We will reduce our flora fauna from our natural ecosystems. So this is a big threat. The rising temperature due to the global warming and climate change. So this is how things are happening. Next, please. So Harike, we have reported in 2005 69 species, and After a few years, 55, and we have lost 14 species due to advent of so many anthropogenic activities. Same way had we can say Roped wetland, 55, recently 32, and we have lost 23 fish species. So this is, by the way, pace of organism we people losing from our mighty water bodies. So if the things will continue with the same pace, the day is not far away. We people will lose these beautiful organisms from our earth, and it can play havoc to our ecosystems. Next, please. So this is how things are. Okay, we are losing our valuable biodiversity from our natural ecosystems with the advent of climate change and global warming. Any questions? Curiosity of your mind. Thank you.
Thank you so much, sir. Your talks are always insightful and valuable, and you have rightly conveyed how the loss of biodiversity is due to the changes which are taking place in the climate, and they are adversely leading to the extinction of many of the species. So we need to take some judicial and concrete step towards that. So now I would like to invite our next keynote speaker, Dr. Rajesh Kumar. He is Assistant Professor in the Department of Biosciences, Himachal Pradesh University. He has more than 9 years of experience in teaching and research. His chief thrust area of research is animal physiology, applied zoology, nutraceuticals, and biodiversity conservation. He has successfully completed two major research projects and two CM startup projects in the area of honeybee physiology, nutrition, and waste management, sponsored by the government of Himachal Pradesh. Dr. Kumar has published more than 100 research publications in renowned journals. He has won 12 awards in various national and international conferences. He has successfully supervised two PhD, one MPhil, and 42 MSc students for their research work. He is a life fellow member of various national and international reputed scientific agencies. We are honored to have him amongst us. Over to you, sir.
Thank you. हमारे यहाँ भी नहीं है हमने हमारा करके रहे हैं हमारे यहाँ पर ऑर्गेनाइजर का सब मिनट में बात करेंगे बहुत जल्दी जल्दी basically is the bridging of hills and plains. I belong to Shimla and before that I am here in plains and I will be talking about very briefly talking about sweet world honeybees or honey or कैसे honey से money बना सकते हैं. Therefore, yesterday Professor Juneja has already elaborated many things about the student and was talking about. Still, I have been trying for you for two slides. I see how things. Now, I'm professionals basically about social economy and sustainable development, how they are doing and let's see next book will be talking on this aspect only. That now these are few things that we are doing. Just want to share with people. अभी पहले प्राइवेट यूनिवर्सिटी में थी और अबाउट 8 years और ये सारा वही का है गवर्नमेंट यूनिवर्सिटी में है तो ऑलरेडी हम काम कर रहे हैं बोल रहे हैं नेक्स्ट न्यूज these are few species that are available in India. Next. Yes, this is the most important species. Wild है ये आप इसको देख सकते हैं आपके घर के आसपास मिल जाएगा ये जैसा डॉक्टर बासर ने बात कही कि बायोडाइवर्सिटी में हमारा डेफिनेशन है बहुत सारे एविडेंट फॉर्म है एंथ्रोपोजेनिक एक्टिविटीज हैं तो ये थोड़ा सा इंसेक्ट भी बहुत ज्यादा डिग्रेड हो रहा है, बहुत पॉपुलेशन डिक्लाइन हो रहा है, अदरवाइज नेक्स्ट दिस इज द डोमेस्टिक स्पीसीज जो हमारे इंडियन बी बोलते हैं, भारतीय मधुमक्खी, और घरों में पाली जाती थी। अब ये भी खत्म होने के कगार पर है, क्योंकि कच्चे घरों में रहती थी, अब कंक्रीट के घर आ गए हैं, तो कंक्रीट के घर में ये रहना पसंद नहीं करती है और खत्म होती चलेगी। नेक्स्ट, इससे पहले जब हम और डॉक्टर यूनिस ऑर्गन सेक्रेटरी हमीरपुर में साथ काम करते थे, तो हमने नैपिस राजा के कुछ हाइव्स ट्राई किए थे, और बहुत कम शहद मिलता है, एक साल में 4-5 किलो शहद मिलता है, और बहुत अच्छा प्योर क्वालिटी हनी होता है इसका। नेक्स्ट, this is what they all are doing right now this country with apis mellifera. जो आप ऑप्शन देखते हैं, पंजाब is rich state in beekeeping also. तो ये जो एपिस mellifera species है, this is the commercial honey bee species, जिससे बहुत अच्छा ज्यादा हम शहद पा सकते हैं। नेक्स्ट, I have my farm also, about 100 of the colonies I'm having right now. We are, investigating for the purpose of science only. We are not doing business over there. No doubt, honey निकलता है तो बेचना तो पड़ेगा, या तो कुछ सज्जन लोग मिल जाएं जिसको फ्री में दे दें प्यार मोहब्बत में, अदरवाइज तो फिर सेल करना ही पड़ता है। नेक्स्ट प्लीज, नेक्स्ट प्लीज, नेक्स्ट प्लीज। ये प्रोडक्ट्स हैं, सब जानते हैं आप। शहद, बहुत अच्छी बात है, हमारे दिमाग में स्ट्राइक की जब हम यहाँ बैठे थे। परसों इनॉग्रेशन हुआ था तो सब ध्यान से हुआ था, और आज क्लोजिंग लेक्चर हो रहा है शहद से। सो राइट फ्रॉम बर्न टू द कैट, हनी इज देयर। आई एम टॉकिंग अबाउट हिंदुइज्म, हिंदू धर्म में ये चलता है। आई एम प्रीटी श्योर कि बाकी जो रिलीजन्स हैं, सिखिज्म, एवन they all much importance of honey in their aspects. So next person is all yes. just previous, ये हनी आप देख रहे हैं, हनी की फ्रेम है, नीचे कल्टिवेटेड हनी है, बट राइट साइड में फॉर्म हनी है। शहद की कीमत 250, 300, 400, 500, मुंह देख के थप्पड़ मारना, वो वाला सिस्टम हो गया आजकल। अदरवाइज तो देसी घी के बराबर का रेट होता था, तो देसी घी 1000 रुपए किलो है। ये जो प्योर हनी है, दिस इज द प्योरेस्ट फॉर्म ऑफ हनी। अब हम सर्च करते हैं कि प्योर हनी कहाँ मिलेगा, हम जहां भी जाते हैं यही क्वेश्चन होता है कि डॉक्टर साहब प्योर हनी कहाँ से मिलेगा। प्योर हनी, फॉर्म हनी, हम ये जो आप फ्रेम देख रहे हैं इसको कट करते हैं और एज इट इज इसको सेल कर देते हैं। 1200 रुपीज पर केजी सेल होता है ये। जब करते हैं लेकिन हम कभी नहीं करते हैं, नेवर। मधुमक्खी नहीं पालनी है, जो मधुमक्खी पाल रहे हैं उनसे सेकंड खरीदिए, 100 किलो सेकंड खरीदिए, बॉटलिंग में लगाइए, 500 रुपए किलो बेच दीजिए, 120 रुपए खर्चा, 380 रुपए पर केजी आपका जो है वो सेविंग हो जाएगा। तो आप देखिए, मक्खी पालेंगे तो कोई बात आ गई नहीं कि पढ़ाई पढ़ाई क्यों की। अगर मक्खी ही पालनी थी, अगर मुर्गे ही पालने थे, जरूरी एमएससी पीएचडी कर लेनी थी, ये भी तो बात आती है ना। गो फॉर स्मार्ट थिंग्स। नेक्स्ट, this is propolis. Next, yes, pollination. Next, now एक मधुमक्खी जो है, एक ड्रॉप हनी की बनाने के लिए उसको इतनी मेहनत करनी पड़ती है। एक ड्रॉप हनी की बनाने के लिए 1200 फूलों पे जाती है। 1 किलो शहद में 500 ड्रॉप्स होती हैं। 1 किलो शहद में 500 ड्रॉप्स होती हैं। 6 लाख फूलों पे विजिट करती है, तब जाके 1 किलो शहद बनता है। और हम डकैतों की तरह जाते हैं और निकाल के ले आते हैं। तो हमारे लिए थोड़ी बना रही है, अपने लिए बनाते हैं। यस, नो डाउट, क्योंकि ह्यूमन बीइंग्स के बेनिफिट की चीज है, एक्सटेंड करनी चाहिए, सेल भी होनी चाहिए, बट थ्रू प्रॉपर मीन्स। नेक्स्ट, यस, मनी स्पिनर्स। अब बात करेंगे कि पैसा कैसे कमाना है। नेक्स्ट, आज की डेट में जो फोकस क्या है, शहद बेचना है। मक्खियां पालने का मतलब ये है, शहद बेचना है। और मक्खियां कौन पालता है? जो कुछ नहीं कर सकता इस दुनिया में, वो मक्खियां पाल लो, है ना, या मुर्गे पाल लो। ऐसा नहीं है। अगर हमने जिनसे पालने हैं, पोल्ट्री फार्म ही बोलना है, तो गो फॉर बॉयलर्स जो 100 रुपए किलो बिकता है, वो कर नाम होगा। कड़कनाथ फार्म एक ईयर इस कंट्री में बड़ा वाला वो ढूंढ मिलता है ना, और उसका जो फ्लैश है मीट है वो 1200 रुपया पर केजी बिकता है, मिलता ही नहीं है, यू नो फाइन। तो मुर्गे पालने हैं तो मुर्गे भी ढंग के पालो जाता है कि पैसा भी बन सके। सो देयर आर मेनी अदर प्रोडक्ट्स दैट आर वेरी वैल्यूएबल एंड इन कंपैरिजन टू हनी बहुत ज्यादा जिनकी कीमत है। नेक्स्ट, नाउ दिस इज व्हाट आई वांट टू शेयर विद यू पीपल, इकोनॉमिक्स इसकी बात करनी थी। कैसे स्टार्ट करें, कितने से स्टार्ट करें, क्या फायदा पॉसिबिलिटी है फायदा होने की। 50 नंबर ऑफ बॉक्सेस से शुरू करना ठीक रहता है। 5-7 डब्बे रखें। देखिए दूध, अगर आपने डेयरी फार्म में दूध ही बेचना है तो एक गाय पाल के थोड़ी काम चलेगा, 10 गाय पालना पड़ेगा ना, तभी दूध बिकेगा और तभी फायदा होगा। 50 बॉक्सेस के साथ जाएंगे तो विल बी स्पेंडिंग 2 लाख रुपीज, सब अप्रोक्सीमेटली 2 लाख इन्वेस्टमेंट करना पड़ेगा और 1 लाख रुपया रिकरिंग कॉस्ट होगी जो हर साल होगी 50 डब्बों को मेंटेन करने के लिए। 3 लाख रुपया आपका खर्चा है अगर आप बी कीपिंग वेंचर स्टार्ट करना चाहते हैं तो 3 लाख रुपया इनिशियली आपको खर्च करना पड़ेगा। नाउ नेक्स्ट स्लाइड, दिस इज व्हाट इज द पॉसिबल आउटपुट इफ यू आर डूइंग इट इन अ साइंटिफिक मैनर। हनी सेलिंग और बाकी चीजें बेच के कॉलोनी रेंट पर देके यू माइट बी एबल टू अर्न समवेयर इन टोटल 4 लाख रुपीज। 3 लाख खर्चा हुआ है, और ध्यान रखिएगा 50 डब्बों से मक्खियां पालने में, बी कीपिंग शुरू करने में फर्स्ट ईयर आपको 4 लाख रुपए आ रहा है। और अगर आप रॉयल जेली एक्सट्रैक्शन सीख लेते हैं जो कि भारत देश में अभी तक साइंटिफिकली एक्सट्रैक्ट नहीं की जा रही है, देयर इज नो एनी कमर्शियल प्रोडक्शन, तो 2 लाख रुपए ऐड करते हैं आप 1 लीटर से 6 लाख रुपया। 3 लाख इन्वेस्टमेंट की, 6 लाख रुपए आया। सेकेंड ईयर में 3 लाख रुपया खर्च नहीं होगा, 2 लाख जो आपने इनिशियली डब्बे खरीदने के लिए इन्वेस्ट किया था, क्योंकि बॉक्सेस तो है आपके पास, तो आपका नेट जो प्रॉफिट है वो एनुअली 5 लाख शुरू हो जाएगा। Bees have very fast reproductive potential. एक दिन में एक रानी मक्खी 2000 अंडे दे सकती है, तो 50 डब्बे जो हैं वो 75 हो जाते हैं, 100 भी कर सकते हैं इफ यू हैव गुड स्किल, तो 50 से 100 हो जाएंगे, तो ये 5 लाख जो है वो 10 लाख हो जाएगा, है ना। जस्ट टू ल्यूर यू पीपल, इतना आसान नहीं है मक्खियां काट, और मेहनत भी बहुत करनी पड़ती है। अगर आप हनी बीज या बी कीपिंग में इंटरेस्ट रखते हैं, कोशिश भी करना चाहते हैं ना, तो आपको जो बॉक्सेस रखे हैं उनके पास जाइए, उनके साथ रहिए, उनके साथ राजस्थान और दूसरी जगह माइग्रेट भी होइए साथ में, फिर पता लगेगा प्रॉब्लम्स कितनी है। डब्बे पैक करो, डब्बे उठाओ, डब्बे ट्रक में डालो, ट्रक चलाओ, रास्ते में पुलिस वाले मिलेंगे, उनको पैसे नहीं देने तो हनी दो, फिर उतारो। There are many, just adding a few funny points in between, but these are very critical problems. हमने एक बार मटौर डिस्ट्रिक्ट कांगड़ा में पड़ता है, वहां से झज्जर के लिए फ्लाइट सॉरी ट्रक में डब्बों के साथ, तो 3 जगह पुलिस वालों ने रोका और हमने बोला कि बॉक्सेस है, मधुमक्खियां हैं। बोलते हमें कैसे पता कि जो अंदर वाला डब्बा है उसमें भी मधुमक्खियां हैं, उतारो सारे डब्बे। तो फिर मरता क्या ना करता, एक डब्बा उठाया शहर का, मैंने कहा तू ले ले भाई, है ना, फिर आगे चल दिए। तो these are very very typical type of problems that beekeepers are facing. Next, these are few benefits that already have been debated. Next, this is we can say our team. On left side, I'm having my students, PhD students, 3 have lined up and 3 are working. Therefore, yesterday 2 were here. And on right side, we have collaborators, Dr. Suresh, Dr. Yunis. They are sitting over here. There is the empty space at the end because I always looks for collaborations. So any of you who want to join us to work in this field, most welcome. We might be doing good things and good work. This topic. Next. Few books that we have launched, published. हिंदी में एक बुक लिखी है, पहले इंग्लिश में लिखी, फिर वो हिंदी में लिखी, अब वो उर्दू में लिखी जा रही है, डॉक्टर यूनिस एडिट कर रहे हैं। तस्वीर है एक हमारे मित्र में मानसा डिस्ट्रिक्ट मानसा में, उसको पंजाबी में एडिट करेंगे। 100 रुपीज कॉस्ट रखी है, फ्री नहीं देंगे किसी फ्री की चीज अच्छी नहीं लगती है ना। तो 100 रुपीज कॉस्ट है, उसमें 100 रेसिपीज हैं। सेहत से क्या क्या डिजीजेस कंट्रोल की जा सकती हैं, मैनेज की जा सकती हैं, बिकॉज कोविड के बाद ये बहुत गया है। होम्योपैथी पे विश्वास आप थोड़ा कम करने लगे हैं, ज्यादा अच्छी बात है। नेक्स्ट प्लीज। These are also few books that we are reading for international publishers, printer and different classes. Next. ये हाल ही में बुक्स का जो लॉन्च हुआ था बटर साहब के द्वारा और साहब के द्वारा। नेक्स्ट। These are the training programs that we use to conduct in this state of Himachal under research that were granted by Dr. Next. Safety training programs. Next. Yes. So, हम करते हैं पश्चिम में को रहने थे जिनको होने से तो समय में कुछ शहर की दुकानें थी, तो कुछ इस तरह से शहर बेच रहे थे। रोड की साइड पे रख दिया था, ना कपड़ों का पता, ना दबों का पता, ना सर का पता। नेक्स्ट। ऐसे नहीं करना है, ऐसे करना है। स्मार्ट बीकीपिंग, स्मार्ट सेलिंग, है ना। कहीं जाने की जरूरत नहीं है, शहर बेचना है, कहीं जाने की जरूरत नहीं है। फ्लिपकार्ट है, अमेजोन है, बहुत सारी सेलिंग साइट्स हैं। अकाउंट बनाइए, आपके पास ऑर्डर आएगा, मोबाइल से आप ऑर्डर को पैक करिए और भेज दीजिए। नो नीड टू गो एनीवेयर। बेचारे बन के काम नहीं हुआ। मधुमक्खी पालक अभी भी बेचारे बने हुए हैं, इसी तरह इकोनॉमी राइज नहीं कर रही है। सबसे पहले ग्रीन रेवोल्यूशन आया, पंजाब ने बहुत कंट्रीब्यूट किया। ब्लू रेवोल्यूशन आया, बहुत कंट्रीब्यूशन हुई। व्हाइट रेवोल्यूशन आया, बहुत कंट्रीब्यूशन हुई। अब स्वीट रेवोल्यूशन भी आ चुका है। हम स्टूडेंट्स के जीके के लिए बता दें, सन 2018 में 13 में ऑनरेबल प्राइम मिनिस्टर मोदी ने नेशनल मनी मिशन लॉन्च किया है, जिसके अंदर स्वीट रेवोल्यूशन के लिए सेपरेट फंड्स क्रिएट किए गए हैं। देयर आर नाउ सेपरेट फंड्स फॉर दिस स्वीट रेवोल्यूशन। पर फंड्स को लेने के लिए तो थोड़ी मासिक के पास फंड्स हैं, कैसे लेने हैं तभी तो चेंजेस कैसे। तो जस्ट कीप ऑन making some aware about the things and funds and all the policies of the government so that you can aware the facilities. Next. So if you will be doing this, beekeeping or bee selling or other business related to this, then you might be attach money like this, है ना। अटैच कर करके आप घर ले जा सकते हैं, बट साइंटिफिक ऐसे ही नहीं चलेगा। जैसा रूटीन में चलता है वैसा नहीं चलेगा। हमने आपको एग्जाम्पल और फिर दिया जो पोल्ट्री का है, कड़कनाथ चिक का, दैट इज वेरी कॉस्टली चिक। पंजाब में तो मेंटेन कर सकते हैं बिकॉज हॉट एरिया में होता है बेसिकली। देयर इज अ ट्राइब, सहारिया ट्राइब इन मध्य प्रदेश, वहां का वो लोकल फॉल था, देसी मुर्गा जिसको हम बोलते हैं। पंजाब में भी होते हैं, हिमाचल में भी होते हैं। तो वहीं से वो उसकी हाइब्रिड करके उसका जो स्पीसीज है उसको कड़कनाथ करके नाम दिया है, और बहुत महंगा बिकता है। कोई भी वेंचर आप करें, सोचें स्किल इंडिया के अंडर, आत्मनिर्भर भारत के अंडर, या किसी भी स्कीम के अंडर आप कोई भी बिजनेस सोचें, तो वो वेरी क्रिटिकल एंड साइंटिफिक, है ना। बेचारा बन के शुरू नहीं करना है। जब हम हिमाचल में होते हैं ना, तो हम बोलते हैं, जब भी हम ट्रेनिंग करने जाते हैं, हिमाचली टोपी, मफलर और हिमाचली पोशाक पहन के साथ बेचना है, तब बिकेगा, ऐसे नहीं बिकेगा। देयर आर लॉट ऑफ पीपल हु आर विजिटिंग, टूरिस्ट हु आर विजिटिंग हिमाचल, पंजाब फ्रॉम इवन फॉरेन कंट्रीज। तो जहां पर साफ सफाई होता है, जहां पर चीज अच्छे देखने को मिलता है, वो बिकता है, अदरवाइज नहीं बिकता है। So that's all from my side. I might have taken 5 minutes extra, but I want to finally share with you people that do the things in a proper manner। और कोई भी चीज है, जैसे आप पढ़ रहे हैं अभी बीएआरसी से, हमारे सीनियर एचपीयू से सीनियर जो रहे हैं वो बोल रहे थे, डॉक्टर जितेंद्र, तो मेरे दिमाग में एक क्वेश्चन आया, हालांकि सेशन लंबा चल गया, तो हमने पूछा नहीं कि हाउ आई कैन रीच बीएआरसी फॉर सम ट्रेनिंग और सम अदर पर्पस। आपको पूछना चाहिए ना, आपके काम की चीज है। हम लोग तो पहुंच चुके हैं जहां पहुंचना था, हम तो अब मजे के लिए जा सकते हैं कि ठीक है डॉक्टर साहब के पास 10 दिन चलेंगे। स्टूडेंट्स फ्रॉम यूआईटी जो यहाँ बैठे हुए हैं, हाउ दे कैन एंड पार,
That is a question for you people from the personality like Dr. Gitendra. So come up with the new things, with the innovative minds, because you people are the future. And I'm very grateful to Dr. Yunus, my lovely junior, Madam Anisha, Madam Shweta, Vice Chancellor साहब. और हमें ऐसा लगता है जब हम नरसों यहाँ आए थे कि हमारा अपना ही कैंपस है. मतलब I'm very lively to this place, और ये कैंपस भी बहुत lively लगता है हमें, अपनापन सा महसूस होता है. So thank you very much for listening, and thank you very much the organizers. Thank you.
Daniel, I have one question. Just out of curiosity, first of all, let me congratulate you for this wonderful talk. Just a quick method without the lab testing. How
जी.
to check the
शहद की क्वालिटी कैसे आंखें बंद करके चेक करें घर बैठे. कांच का गिलास लीजिए, पानी से भर दीजिए, टेबल पे रख दीजिए, 1 चम्मच शहद का भरिए, गिलास में डाल दीजिए. अगर सीधा नीचे सेटल डाउन होता है, प्योर. अगर छरता है, डिस्पर्स होता है, अडल्टर्ड. सीधा फंडा है. देयर इज नो एनी लैब टेस्ट सर, ये भी बता दूं.
this is practical thing.
दिस इज वेरी प्रैक्टिकल. तजुर्बेकार जो हमारे कीपर्स रहे हैं और अभी भी काम करते हैं, ये उनका तजुर्बा है. तजुर्बे काम आते हैं. आपने भी बोला कि ट्रेडिशनल चीजों पे अभी भी पोटेंशियोमेट्रिक पे रिलाई करता है बार. समझने की बात है. कहा सर वॉज द पार्ट ऑफ चंद्रयान 3, टेक्नोलॉजी डेवलप करी, उसके लिए मटेरियल डेवलप करे, बट बेस्ड अपॉन पोटेंशियोमेट्रिक. दैट इज अ वंडरफुल थिंग. तो यहाँ भी वही बात है.
Quite important.
क्वाइट इंपॉर्टेंट. तो यहाँ भी वही बात है. लैब में कोई टेस्ट नहीं बना है अभी. आई एम प्लानिंग टू डेवलप नैनो चिप फॉर क्वालिटी टेस्टिंग ऑफ हनी, बट आई रिक्वायर सम नैनो साइंटिस्ट. एक कोलैबोरेटिव टीम चाहिए. अदरवाइज दिस इज द सिंपलेस्ट मेथड.
Perfect.
Sir,
kindly share your number. One of my friends is interested in beekeeping.
Sure, Dr. Yonis is there, or you can write right now 98054.
Thank you so much, sir. It was indeed a highly sorted session by you. Sir. Thank you so much. You have kept your talk very simple and
easy to understand. Sir has deeply explained the economic importance of beekeeping, and moreover, he has also emphasized how we can generate money and start up entrepreneurship with with the honey keeping. Thank you so much, sir, for your session. Now, I would like to extend my cordial welcome to our respected Registrar Sir, Dr. Aneet Kumar, who has joined us, and also Principal Santaba Bhag Singh International School, Mr. Ranjit Singh. Thank you so much, sir, for gracing this occasion.
And Vice Chancellor has advised me to give special thanks to Dr. Rajesh for arrangement of our chief guest, Professor R.C. Sobti Padam Shri Award. We are very thankful to sir for arranging us such arrangement.
Now I would like to request our worthy Vice Chancellor Sir and Registrar Sir and our society members to please honor our guest of honor for the day, Dr. Omkar Singh Badach, Associate Professor, Punjabi University, Patiala. Dr. Gitendra Singh, Scientific Officer F, Department of Atomic Energy, BARC, Tarapur, Maharashtra. Thank you so much, all of you. Now we proceed for the lunch break. Please honor Dr. Rajesh and Dr. Suresh with the certificates. Thank you so much, all of you, for joining us. Now we proceed for the lunch break, and the valedictory session will begin immediately after the lunch. So all are requested to join us.
मिलेगा तो आराम दे नाल So I am very happy that I have been invited in this university as a guest to address the students, eminent scientists. First of all, I would like to say that the topic chosen for the conference, that is empowering sustainability, bringing science, technology, and climate resilience. Now, if you see in depth the meaning of the topic of the conference, that is empowering sustainability. So, to empower sustainability, that is the dire need of the present days. And this empowering sustainability, it cannot be brought about together without the combination of science, technology. So science, the technology is dependent on the science, and this climate resilience, it is dependent on the technology. I think you are aware the meaning of this resilience. One who can bear everything, every adverse thing can be feared by anyone. That is the resilient or resilience. Our environment, our climate is bearing all the adverse conditions which have been made by the human disturbance. So the topic is very relevant and it is the need of the present day that this science, technology, climate resilience should be combined with one another so that we can save our environment. So respected Chancellor Sir, my very dear friend, Vice Chancellor Dr. Taramjeet Singh, and when I was in the university, I could see that there are many students who have been taught by me. First, I would like to recall Dr. Purushottam Singh. When I was doing PhD, he was doing MSc at that time. Then Dr. Indu is there. He was my student. Dr. Vikas is there. Dr. Vikrant is there. So I am very happy to see them all rising. So coming to the talk, that is the climate resilience. How science and technology is responsible for this resilience. Can I have some light here? Anyhow, no. Thank you. So coming to the topic, in the recent time, the human activities are fast disturbing the natural ecosystem. As I have just told you, that our climate is bearing all the disturbances. And the main cause for these disturbances is the human activities. Whatever the activities are there, whatever the fertilizer we are using, whatever the fossil fuels we are consuming, or whatever the pesticides, fungicides we are spraying on the crops, all these are responsible for this climate change. So the climate change, they are putting stress on the agricultural crops. Every crop, has to be sprayed with the pesticide, fungicides, insecticides. The important climate-based abiotic stresses in the plants are like drought or water scarcity. Now, due to this climate change, all these crops, they are facing the water scarcity, salinity, then excessive heat in the summer and cold in the winter. Now you can see nowadays excessive cold is there. In the summer season, you will see that excessive hot season is there. Unbearable temperature in the summer season is there. And so the crops, they are also unable to bear all these climatic changes. It is a challenge to science and technology to develop climate resilient crops which can fight drought, heat, cold, and the soil toxin. Now, the plants or the crops, they are living being like us. As we are breathing, they are also breathing. As we are doing the metabolic activities, they are all doing the metabolic activity and they need the congenial environment. But due to the human activities, this congenial environment that is not available to our crops. That is why the scientists, they are searching and doing regular researches so that to improve the crops in order to face all these adverse environmental conditions. So the theme of this conference, as I have already told you, has nicely been selected by the organizing secretaries or organizers, bringing science and technology for climate resilience. So all these three topics, science, technology, and climate, as I have already told you, they are dependent on one another. So it is definitely going to benefit the finding out the ways and means to develop the climate adverse climatic resilient crops. The collaboration of biological sciences and technology gave rise to new field of science, biotechnology, which work in this direction. The climatic changes, they are converting our fertile agriculture into non-fertile by increasing the alkalinity, acidity, desertification, then the biological or microorganisms, they play a very important role in the production of our crops, biological microorganisms. So they are being killed by the acidity of the soil, by the alkalinity of the soil, or when we put fertilizers, or when we put these pesticides, insecticides on the crop. So blue-green algae have the potentiality to reduce the acidity and alkalinity and reclamation of the agricultural land to restoring its fertility. So this blue-green algae, it is also the microorganism which is responsible to face the adverse climatic condition in order to increase the production of the crop plants. The agricultural scientists, they are highly concerned regarding climatic changes and making all out efforts to develop resistant crop varieties so as to feed the ever increasing population. When these crops, they have to face the adverse climatic condition, naturally whole of their metabolic system is disturbed. And when the metabolic system of the plant body is concerned, then they are unable to produce more and more. Whereas our population is increasing day by day, and on the other hand, due to changes in the climatic conditions, the crop production is being reduced. So currently, our country is facing a challenge of producing the adequate food to meet the demands of ever increasing population from shrinking natural resources, intensification of agriculture through enhanced productivity, and resource use efficiency has to be the main focus as competition for land and water are increasing from non-farming sectors. Further, in recent years, the climate change and its vulnerability are emerging a major challenges to Indian agriculture. In view of these, immediate thrust is needed on enhanced production with reduced natural resources under a variable climate. So this climate resilience, that is the very, very important burning topic of these days. The development and identification of climatic resistance crop varieties with enhanced tolerance to heat, drought, flooding, killing, salinity stresses, they are very, very essential in order to sustain the improved crop yields to cope up with the challenges of the climatic changes. So it means heat. We have to reduce or we have to reduce the global warming, that is this heating effect on the plants. Then drought, we have to produce the drought resistant plants. Then flooding, flood resistant plants. You know, last year there were great floods in the Punjab and whole of the rice crop was destroyed. So we have to face all these situations. As a scientist, I can say that most of the scientists, they are working in these type of the searches so as the plants, they become resistant to the climatic changes. That is the climatic resilience. Climatic resilience, as you know, it is the ability to anticipate, prepare for, and respond to hazardous events or disturbances related to the climate. So, once again, I will say that all these disturbances, they are due to the human activity. We are responsible. All of us are responsible for this climatic change. Now, improving climatic resilience involves the assessing how climate change will create new or alters the current climatic related risk and taking steps to better cope up with these risks. So how to protect our crops from all these risks of salinity, drought, acidity, etc. Then climate resilient crops, they are the crops and the crop varieties that have enhanced tolerance to biotic and abiotic stresses. I think you are familiar with both these terms, biotic and abiotic stresses. In order to create mass awareness for adoption of climatic resilient technology, the Prime Minister of India on 28 September 2021 dedicated 35 crop varieties with special traits via video conferencing. The event was organized at the Indian Agricultural Research Institute, New Delhi, ICAR, Indian Council of Agriculture Research. These 35 new crop varieties with special traits such as climatic resilience and nutritional rich contents have been developed by ICAR to address the twin challenges of climatic change and malnutrition. These include a drought tolerance variety of chickpea, wilt and sterility mosaic resistance pigeon pea, early maturing varieties of soybean, disease resistant varieties of rice, and biofortified varieties of wheat, pearl millet, maize, and chickpea, quinoa, buckwheat, winged bean, and faba bean. These special trait crops varieties, they also include those that address the anti-nutritional factor found in some crops that adversely affect the human and animal health. So in the last, I will say that it is not only the plants which are affected by this climatic change. It is the human being also and all the living organisms, even the smallest living organism, that is the viruses, they are also affected by this climatic change. So our duty is that whatever we learn from this conference, we should apply in our daily life. There are many activities which we can avoid or which we can perform in order to save our environment. So with this brief introduction, I once again thank the Vice Chancellor and the organizers of this conference who have invited me to this conference. Thank you very much. Thank you.
Thank you so much, sir. Being a plant biochemist, I can feel the pain that is being faced by plants. And of course, our duty to take appropriate efforts to bridge science and technology for empowering sustainability. Thank you so much. We have been graced by the
मिलेगा तो आराम दे नाल So I am very happy that I have been invited in this university as a guest to address the students, eminent scientists. First of all, I would like to say that a topic chosen for the conference, that is empowering sustainability, bringing science, technology, and climate resilience. Now, if you see in depth the meaning of the topic of the conference, that is empowering sustainability. So, to empower sustainability, that is the dire need of the present days. And this empowering sustainability, it cannot be brought about together without the combination of science, technology. So science, the technology is dependent on the science, and this climate resilience, it is dependent on the technology. I think you are aware the meaning of this resilience. One who can bear everything, every adverse thing can be feared by anyone. That is the resilient or resilience. Our environment, you know, our climate is bearing all the adverse conditions which have been made by the human disturbance. So the topic is very relevant, and it is the need of the present day that this science, technology, climate resilience should be combined with one another so that we can save our environment. So respected Chancellor Sir, my very dear friend, Vice Chancellor Dr. Taramjeet Singh, and by me, first I would like to recall Dr. Purushottam Singh. When I was doing PhD, he was doing MSc at that time. Then Dr. Indu is there. He was my student. Dr. Vikas is there. Dr. Vikrant is there. So I am very happy to see them all rising. So coming to the talk, that is the climate resilience. How science and technology is responsible for this resilience. Can I have some light here? Anyhow, no. Thank you. Now coming to the topic, in the recent time, the human activities are fast disturbing the natural ecosystem. As I have just told you, that our climate is bearing all the disturbances. And the main cause for these disturbances is the human activities. Whatever the activities are there, whatever the fertilizer we are using, whatever the fossil fuels we are consuming, or whatever the pesticides, fungicides we are spraying on the crops, all these are responsible for this climate change. So the climate change, they are putting stress on the agricultural crops. Every crop, has to be sprayed with the pesticide, fungicides, insecticides. The important climate-based abiotic stresses in the plants are like drought or water scarcity. Now, due to this climate change, all these crops, they are facing the water scarcity, salinity, then excessive heat in the summer and cold in the winter. Now you can see nowadays excessive cold is there. In the summer season, you will see that excessive hot season is there. Unbearable temperature in the summer season is there. And so the crops, they are also unable to bear all these climatic changes. It is a challenge to science and technology to develop climate resilient crops which can fight drought, heat, cold, and the soil toxin. Now, the plants or the crops, they are living being like us. As we are breathing, they are also breathing. As we are uh, doing the metabolic activities, they are all doing the metabolic activity, and they need the congenial environment. But due to the human activities, this congenial environment that is not available to our crops. That is why the scientists, they are searching and doing regular researches so that to improve the crops in order to face all these adverse environmental conditions. So the theme of this conference, as I have already told you, has nicely been selected by the organizing secretaries or organizers, bringing science and technology for climate resilience. So all these three topics, science, technology, and climate, as I have already told you, they are dependent on one another. So it is definitely going to benefit the finding out the ways and means to develop the climate adverse climatic resilient crops. The collaboration of biological sciences and technology gave rise to new field of science, biotechnology, which work in this direction. The climatic changes, they are converting our fertile agriculture into non-fertile by increasing the alkalinity, acidity, desertification, then the biological or microorganisms, they play a very important role in the production of our crops, biological microorganisms. So they are being killed by the acidity of the soil, by the alkalinity of the soil, or when we put fertilizers, or when we put these pesticides, insecticides on the crop. So blue-green algae have the potentiality to reduce the acidity and alkalinity and reclamation of the agricultural land to restoring its fertility. So this blue-green algae, it is also the microorganism which is responsible to face the adverse climatic condition in order to increase the production of the crop plants. The agricultural scientists, they are highly concerned regarding climatic changes and making all out efforts to develop resistant crop varieties so as to feed the ever increasing population. When these crops they have to face the adverse climatic condition, naturally whole of their metabolic system is disturbed. And when the metabolic system of the plant body is concerned, then they are unable to produce more and more. Whereas our population is increasing day by day, and on the other hand, due to changes in the climatic conditions, the crop production is being reduced. So currently, our country is facing a challenge of producing the adequate food to meet the demands of ever increasing population from shrinking natural resources, intensification of agriculture through enhanced productivity, and resource use efficiency has to be the main focus as competition for land and water are increasing from non-farming sectors. Further, in recent years, the climate change and its vulnerability are emerging a major challenges to Indian agriculture. In view of these, immediate thrust is needed on enhanced production with reduced natural resources under a variable climate. So this climate resilience, that is the very, very important burning topic of these days. The development and identification of climatic resistance crop varieties with enhanced tolerance to heat, drought, flooding, killing, salinity stresses, they are very, very essential in order to sustain the improved crop yields to cope up with the challenges of the climatic changes. So it means heat. We have to reduce or we have to reduce the global warming, that is this heating effect on the plants. Then drought, we have to produce the drought resistant plants. Then flooding, flood resistant plants. Last year there were great floods in the Punjab and whole of the rice crop was destroyed. So we have to face all these situations. As a scientist, I can say that most of the scientists, they are working in these type of the searches so as the plants, they become resistant to the climatic changes. That is the climatic resilience. Climatic resilience, as you know, it is the ability to anticipate, prepare for, and respond to hazardous events or disturbances related to the climate. So, once again, I will say that all these disturbances, they are due to the human activity. We are responsible. All of us are responsible for this climatic change. Now, improving climatic resilience involves the assessing how climate change will create new or alters the current climatic related risk and taking steps to better cope up with these risks. So how to protect our crops from all these risks of salinity, drought, acidity, etc. Then climate resilient crops. They are the crops and the crop varieties that have enhanced tolerance to biotic and abiotic stresses. I think you are familiar with both these terms, biotic and abiotic stresses. In order to create mass awareness for adoption of climatic resilient technology, the Prime Minister of India on 28 September 2021 dedicated 35 crop varieties with special traits via video conferencing. The event was organized at all at the Indian Agricultural Research Institute, New Delhi, ICAR, Indian Council of Agriculture Research. These 35 new crop varieties with special traits such as climatic resilience and nutritional rich contents have been developed by ICAR to address the twin challenges of climatic change and malnutrition. These include a drought tolerance variety of chickpea, wilt and sterility mosaic resistance pigeon pea, early maturing varieties of soybean, disease resistant varieties of rice, and biofortified varieties of bean, pearl millet, maize, and chickpea, quinoa, buckwheat, winged bean, and faba bean. These special trait crops varieties, they also include those that address the anti-nutritional factor found in some crops that adversely affect the human and animal health. So in the last, I will say that it is not only the plants which are affected by this climatic change. It is the human being also and all the living organisms, even the smallest living organism, that is the viruses, they are also affected by this climatic change. So our duty is that whatever we learn from this conference, we should apply in our daily life. There are many activities which we can avoid or which we can perform in order to save our environment. So with this brief introduction, I once again thank the Vice Chancellor and the organizers of this conference who have invited me to this conference. Thank you very much. Thank you.
Thank you so much, sir. Being a plant biochemist, I can feel the pain that is being faced by plants. And of course, our duty to take appropriate efforts to bridge science and technology for empowering sustainability. Thank you so much. We have been graced by the
मिलेगा तो आराम दे नाल So I am very happy that I have been invited in this university as a guest to address the students, eminent scientists. First of all, I would like to say that the topic chosen for the conference, that is empowering sustainability, bringing science, technology, and climate resilience. Now, if you see in depth the meaning of the topic of the conference, that is empowering sustainability. So, to empower sustainability, that is the dire need of the present days. And this empowering sustainability, it cannot be brought about together without the combination of science, technology. So science, the technology is dependent on the science, and this climate resilience, it is dependent on the technology. I think you are aware the meaning of this resilience. One who can bear everything, every adverse thing can be feared by anyone. That is the resilient or resilience. Our environment, you know, our climate is bearing all the adverse conditions which have been made by the human disturbance. So the topic is very relevant, and it is the need of the present day that this science, technology, climate resilience should be combined with one another so that we can save our environment. So, respected Chancellor Sir, my very dear friend, Vice Chancellor Dr. Taramjeet Singh, and when I was in the university, I could see that there are many students who have been taught by me. First, I would like to recall Dr. Purushottam Singh. When I was doing PhD, he was doing MSc at that time. Then Dr. Indu is there. He was my student. Dr. Vikas is there. Dr. Vikrant is there. So I am very happy to see them all rising. So coming to the talk, that is the climate resilience. How science and technology is responsible for this resilience. Can I have some light here? Anyhow, no. Thank you. So coming to the topic, in the recent time, the human activities are fast disturbing the natural ecosystem. As I have just told you, that our climate is bearing all the disturbances. And the main cause for these disturbances is the human activities. Whatever the activities are there, whatever the fertilizer we are using, whatever the fossil fuels we are consuming, or whatever the pesticides, fungicides we are spraying on the crops, all these are responsible for this climate change. So the climate change, they are putting stress on the agricultural crops. Every crop, you know, has to be sprayed with the pesticides, fungicides, insecticides. The important climate-based abiotic stresses in the plants are like drought or water scarcity. Now, due to this climate change, all these crops, they are facing the water scarcity, salinity, then excessive heat in the summer and cold in the winter. Now, you can see nowadays, excessive cold is there. In the summer season, you will see that excessive hot season is there. Unbearable temperature in the summer season is there. And so the crops, they are also unable to bear all these climatic changes. It is a challenge to science and technology to develop climate resilient crops which can fight drought, heat, cold, and the soil toxin. Now, the plants are the crops. They are living being like us. As we are breathing, they are also breathing. As we are doing the metabolic activities, they are all doing the metabolic activity, and they need the congenial environment. But due to the human activities, this congenial environment that is not available to our crops. That is why the scientists, they are searching and doing regular researches so that to improve the crops in order to face all these adverse environmental conditions. So the theme of this conference, as I have already told you, has nicely been selected by the organizing secretaries or organizers, bringing science and technology for climate resilience. So all these three topics, science, technology, and climate, as I have already told you, they are dependent on one another. So it is definitely going to benefit the finding out the ways and means to develop the adverse climatic resilient crops. The collaboration of biological sciences and technology gave rise to new field of science, biotechnology, which work in this direction. The climatic changes, they are converting our fertile agriculture into non-fertile by increasing the alkalinity, acidity, desertification, then the biological or microorganisms, they play a very important role in the production of our crops, biological microorganisms. So they are being killed by the acidity of the soil, by the alkalinity of the soil, or when we put fertilizers, or when we put these pesticides, insecticides on the crop. So blue-green algae have the potentiality to reduce the acidity and alkalinity and reclamation of the agricultural land to restoring its fertility. So this blue-green algae, it is also the microorganism which is responsible to face the adverse climatic condition in order to increase the production of the crop plants. The agricultural scientists, they are highly concerned regarding climatic changes and making all out efforts to develop resistant crop varieties so as to feed the ever increasing population. When these crops, they have to face the adverse climatic condition, naturally whole of their metabolic system is disturbed. And when the metabolic system of the plant body is concerned, then they are unable to produce more and more. Whereas our population is increasing day by day, and on the other hand, due to changes in the climatic conditions, the crop production is being reduced. So currently, our country is facing a challenge of producing the adequate food to meet the demands of ever increasing population from shrinking natural resources, intensification of agriculture to enhanced productivity, and resource use efficiency has to be the main focus as competition for land and water are increasing from non-farming sectors. Further, in recent years, the climate change and its vulnerability are emerging a major challenges to Indian agriculture. In view of these, immediate thrust is needed on enhanced production with reduced natural resources under a variable climate. So, this climate resilience, that is the very, very important burning topic of these days. The development and identification of climatic resistance crop varieties with enhanced tolerance to heat, drought, flooding, killing, salinity stresses, they are very, very essential in order to sustain the improved crop yields to cope up with the challenges of the climatic changes. So it means heat. We have to reduce or we have to reduce the global warming, that is this heating effect on the plants. Then drought, we have to produce the drought resistant plants. Then flooding, flood resistant plants. You know, last year there were great floods in the Punjab and whole of the rice crop was destroyed. So we have to face all these situations. As a scientist, I can say that most of the scientists, they are working in these type of the searches so as the plants, they become resistant to the climatic changes. That is the climatic resilience. Climatic resilience, as you know, it is the ability to anticipate, prepare for, and respond to hazardous events or disturbances related to the climate. So, once again, I will say that all these disturbances, they are due to the human activity. We are responsible. All of us are responsible for this climatic change. Now, improving climatic resilience involves the assessing how climate change will create new or alters the current climatic related risk and taking steps to better cope up with these risks. So how to protect our crops from all these risks of salinity, drought, acidity, etc. Then climate resilient crops, they are the crops and the crop varieties that have enhanced tolerance to biotic and abiotic stresses. I think you are familiar with both these terms, biotic and abiotic stresses. In order to create mass awareness for adoption of climatic resilient technology, the Prime Minister of India on 28 September 2021 dedicated 35 crop varieties with special traits via video conferencing. The event was organized at the Indian Agricultural Research Institute, New Delhi, ICAR, Indian Council of Agriculture Research. These 35 new crop varieties with special traits such as climatic resilience and nutritional rich contents have been developed by ICAR to address the twin challenges of climatic change and malnutrition. These include a drought tolerance variety of chickpea, wilt and sterility mosaic resistance pigeon pea, early maturing varieties of soybean, disease resistant varieties of rice, and biofortified varieties of wheat, pearl millet, maize, and chickpea, quinoa, buckwheat, winged bean, and faba bean. These special trait crops varieties, they also include those that address the anti-nutritional factor found in some crops that adversely affect the human and animal health. So in the last, I will say that it is not only the plants which are affected by this climatic change. It is the human being also and all the living organisms, even the smallest living organism, that is the viruses, they are also affected by this climatic change. So our duty is that whatever we learn from this conference, we should apply in our daily life. There are many activities which we can avoid or which we can perform in order to save our environment. So with this brief introduction, I once again thank the Vice Chancellor and the organizers of this conference who have invited me to this conference. Thank you very much. Thank you.
Thank you so much, sir. Being a plant biochemist, I can feel the pain that is being faced by plants. And of course, our duty to take appropriate efforts to bridge science and technology for empowering sustainability. Thank you so much. We have been graced by the
मिलेगा तो आराम दे नाल So I am very happy that I have been invited in this university as a guest to address the students, eminent scientists. First of all, I would like to say that the topic chosen for the conference, that is empowering sustainability, bringing science, technology, and climate resilience. Now, if you see in depth the meaning of the topic of the conference, that is empowering sustainability. So, to empower sustainability, that is the dire need of the present days. And this empowering sustainability, it cannot be brought about together without the combination of science, technology. So science, the technology is dependent on the science, and this climate resilience, it is dependent on the technology. I think you are aware the meaning of this resilience. One who can bear everything, every adverse thing can be feared by anyone. That is the resilient or resilience. Our environment, you know, our climate is bearing all the adverse conditions which have been made by the human disturbance. So the topic is very relevant and it is the need of the present day that This science, technology, climate resilience should be combined with one another so that we can save our environment. So respected Chancellor Sir, my very dear friend,
The society members, we are thankful that you have graced this occasion. Before we move on to the valedictory session, I would like to call the students of BSc Agriculture for their cultural performance. Thank you so much, students, for such energetic performance. Now I would like to invite one of our faculty member, Dr. Satnam Singh, for delivering his poem.
ਸਤਿ ਸ਼੍ਰੀ ਅਕਾਲ ਜੀ ਸਾਰਿਆਂ ਨੂੰ। ਤੇ ਮੈਂ ਜੋ ਪੋਇਮ ਸੁਣਾਉਣ ਜਾ ਰਿਹਾ ਇਹ ਹੈਗੀ ਡਾਕਟਰ ਜਗਤਾਰ, ਇੱਕ ਪੋਇਟ ਹੋਏ ਪੰਜਾਬ ਦੇ, ਉਹਨਾਂ ਨੇ ਮਤਲਬ ਲਿਖੀ ਹੋਈ ਆ। ਬੜੀ ਇਹ ਸਪੈਸ਼ਲੀ ਸਟੂਡੈਂਟਸ ਲਈ ਆ, ਤੇ ਕਿਉਂਕਿ ਇਹ ਸਾਨੂੰ ਕਾਫੀ ਮੋਟੀਵੇਟ ਕਰਦੀ ਆ। ਤੇ ਮੈਂ ਨਾਲ ਕਿਉਂਕਿ ਮਤਲਬ ਕਿ ਬੇਸੁਰਾ ਨਾ ਹੋਵਾਂ, ਇਸ ਕਰਕੇ ਮੈਂ ਇਹਦੇ ਨਾਲ ਆਪਣੇ ਮਤਲਬ ਕਿ ਹਾਰਮੋਨੀਅਮ ਵੀ ਪਲੇ ਕਰੂੰਗਾ ਇਹਦੇ ਵਿੱਚੋਂ ਹੀ ਆਪਣੇ ਟੈਪ ਤੋਂ। ਥੈਂਕ ਯੂ। हर मोड़ ते सलीबा, हर पैर ते हनेरा, हर मोड़ ते सलीबा, हर पैर ते हनेरा, फिर भी रुके ना साका भी देख जेरा, हर मोड़ ते सलीबा, हर पैर ते हनेरा, पैरां च बेड़ियां ने नचदे ने लोक फिर भी, पैरां च बेड़ियां ने नचदे ने लोक फिर भी, क्यों देख देख उडदा चेहरे दा रंग तेरा, हर मोड़ ते सलीबा, हर पैर ते हनेरा, किन्नी कुदेर आँख तरती हनेर जरदी, किन्नी कुदेर रहिंदा खामोश खून मेरा, हर मोड़ ते सलीबा, हर पैर ते हनेरा, फिर भी असी रुके ना साका भी देख जेरा, हर मोड़ ते सलीबा, हर पैर ते हनेरा, मेरे भी पैर चुम के एक दिन कहेगी बेड़ी, मेरे भी पैर चुम के एक दिन कहेगी बेड़ी, आज शुक्र है कि आया है अंत महबूब मेरा, हर मोड़ ते सलीबा, हर पैर ते हनेरा। थैंक यू वेरी मच।
Thank you so much, sir. Before we move forward towards the valedictory, I would like to request all the dignitaries that we have an achievement amongst one of our faculty, Dr. Shalu Vyas. She has written a solo book on the world of horticulture. And I would like to request Vardi Babaji, Secretary Sir, and respected VC Sir, with Registrar Sir and the society members to please release her book. It's a great achievement. She has written a solo book. Thank you so much, all of you. What an uplifting and productive days these have been with a number of informative and insightful sessions. We extend our sincere gratitude to all the speakers, panelists, and participants for making this conference a great success. We hope you all have gained valuable knowledge and made important connections during these 3 days. So now I would like to invite the organizing secretary of the conference, Dr. Yunus, to please give a review of these 3 days.
Very good afternoon to all present over the here. Respected Babaji, respected Vice Chancellors, Registrar, Dean Academics, Deans of various schools, faculty members, and their students. 3 days national conference on empowering sustainability, bridging science, technology, and climate resilience, sponsored by DST, Sub Government of India, New Delhi, supported by Punjab Pollution Control Board, organized by University of Natural Sciences in association with ICT Academy, SO Research Lab, under the aegis of MOE IIC and IQSC cell, was successfully organized in UIS Sant Baba Boxing University during 17 to 19 January 2024. The conference was inaugurated on very pious day, Guru Purab, on 17 January, the birth anniversary of Sri Govind Singh Ji, with the kind blessings of Sant Baba Manmohan Singh Ji, Honorable Chancellor of this university. The chief guest of the inaugural session was Professor R.C. Sobti, Padam Shri Awardee and Vice Chancellor of Punjab University, Chandigarh, and Baba Sahib Bhimrao in the Bhimrao NGP University, Lucknow. And also, he is internationally recognized scientist and academician. In these 3 days, there was 3 keynote addresses, one on each day, 20 lead lectures, 8 technical sessions, 2 oral sessions, and 1 poster session through offline mode, and 4 virtual sessions. More than 200 participants attended the conference, presenting different fields of science from more than 5 states. All the technical sessions were informative and interactive. Students actively participated in the technical as well as oral sessions, clear their doubts and queries. Approximately 30 researchers present their research work in oral session. They were asked questions by the experts and or other participants, whereas suggestions were also made by experts to do better in their research work. More than 20 researchers and students present their work through poster presentation. The chairman of poster session evaluated the posters and interacted with the presenters. Healthy discussion took place between the experts and the presenters. About 50 participants present their research work through virtual mode. Their research findings were thoroughly discussed and analyzed by the experts. A copy of recommendation and proceeding of the conference shall be sent to funding agencies and supporting sponsors. All I, on the behalf of organizing committee, express my sincere gratitude to DST Serve for providing financial assistance of 90,000. And we are also thankful to Punjab Pollution Control Board for providing financial support of 1 lakh rupees to organize this conference. We are indebted to the eminent speakers and resource person who came here out of their hectic schedule and granted and graced this occasion. We are also thankful to participants from various institutions who came and presented their research work and made this event a successful one. We are also thankful to our Honorable Chancellor Sir Sant Manmohan Singh Ji, respected Vice Chancellor, Registrar, Dean, Directors, faculty members, students, technical and non-teaching staff who helped to make this event a successful one. We hope you might have enjoyed the lecture, food, accommodation, and camps as well as. Thank you once again.
Thank you, sir. A dream you dream alone is just a dream. A dream you dream together is a reality. So now we move further to the award ceremony. So the first and the foremost award on the auspicious occasion of birth anniversary of Shri Guru Gobind Singh Ji, Sant Baba Pak Singh University presents the Sant Baba Malkeet Singh Ji Memorial Environmentalist of the Year 2023 award to Professor Dr. Adarsh Palvij for his leadership in linking science, public policy, and citizen engagement to address urgent issues of global environmental change and empowering sustainability. He was also the chief guest of the day, but due to some unavoidable circumstances, he could not be present physically with us. But Sir has connected with us online. Now, I would like to request Dr. Indu Sharma to please give a brief introduction.
Thank you, Dr. Aksh. And I'm grateful to Dr. Adarsh Palve, who has joined us virtually, even after having a very busy schedule. At present, he is sitting at some place where it is difficult for him to connect with us. He was eager to join us today, but in morning, he informed us that due to some issues which were unavoidable, he could not join us. So I'm really grateful that he is my teacher. He has been my mentor. And when I joined PhD, he was there as a teacher. And when I joined my first job, he was the person who was heading the department. And whenever I meet him, he's really a very down to earth person, a very simple human being. And he has many achievements to him. He's working for the social welfare. Dr. Adarsh Palve is presently the chairman of Punjab Pollution Control Board. He is also the independent director in HLL Life Care Limited, Mohali, and he is renowned environmentalist as well as he is the professor in the Department of Botanical and Environmental Sciences at Guru Nanak Dev University, Amritsar. He is also the president of Vigyan Parishad Panchnath, VPP, Vishna Bharati or Vibha, which is a scientific movement with Swadeshi spirit of the Punjab. He is having teaching and the research experience of more than 30 years, and to his credit, he is having more than 130 publications, 2 patents, and his cumulative impact factor is of 85. H index is of 32. He has supervised more than 14 students and at present is supervising 8 PhD students. He has also received various distinguished awards like Distinguished Teachers Award 2012, Environmentalist of the Year Award 2016, 2018, 2022. He has also worked as the director of UGC Human Resource Development Center and project coordinator of Rashtriya Uchstar Shiksha Abhiyan Government of India. His academic leadership, governance of various institutions has made him capable of being nominated as the chairman of State Pollution Control Board by the Governor of Punjab with effect from 22nd July 2021. And he is only the professional member of the state level Environment Impact Assessment Authority, Punjab, which has been notified by the Gazette of India notification number 474 dated 3rd February 2021 by the Ministry of Environment, Forest and Climate Change, Government of India, New Delhi, for granting environmental clearances of the major development projects in the state. His role is also as a guest professor in Gifu University, Japan. He's the life member, chairman, member of various scientific and advisory units and bodies like Senate, BOCs, etc. And he is basically involved in conducting various numerous workshops, lecture awareness programs. In 2018, Department of Agriculture and the Life Sciences, they have invited him in the university and he has established the vermicompost unit in the university. Thereafter, he also gave the hands-on training to the farmers in the nearby villages. And uh, always he's there for the university and He is the man who is basically having the very good vision, and he says that we should improve ourselves. So, according to him, the change must start from the person instead of depending upon the circumstances. So, Sant Baba Bhag Singh University is uh, presenting Sant Baba Malki Singh Ji Memorial Environmentalist of the Year 2023 award to Professor Dr. Adarsh Palve on 19th of January 2024 on the auspicious occasion of birth anniversary of Shri Guru Gobind Singh Ji. And on the award, there is a citation which is I'm going to read for you. It is around 250 words. So, according to the citation, the most dynamic environmentalist, proficient administrator, esteemed academician, and renowned researcher, Professor Dr. Adarsh Palve, presently chairman of Punjab Pollution Control Board, independent director in HLL Life Care Limited, Ministry of Health and Family Welfare, Government of India, professor and former head, Department of Botanical and Environmental Sciences, Guru Nanak Dev University, Amritsar, and President Vigyan Parishad Panchnath VPP, Vijna Bharati or Vibha, a science movement with the Swadeshi spirit. Punjab is a source of inspiration and motivation to the people. Professor Vic is instrumental in organizing numerous community awareness programs and stimulating the scientific research for the welfare of society. He is the visionary man behind initiating and establishing various vermicomposting startup units to promote the organic agriculture and also to achieve Swachh Bharat mission. Dr. Vic advocates the use of earthworms through vermitechnology to address the issues of waste management. Under his guidance, Sant Baba Bhag Singh University also established the vermicompost unit, provided hands-on training to the farmers of nearby villages, and focusing on the solution to various environment-related initiatives. The management and administration of Sant Baba Bhag Singh University is pleased to honor Professor Dr. Adarsh Palve for his exemplary works for revolutionizing our understanding of vermitechnology, earthworm ecology, and solid waste management, innovative contributions to the assess bioactivities of glucosinolates, and demonstrating the pollution control regulations. On the occasion of birth anniversary of Shri Guru Gobind Singh Ji, Sant Baba Bhag Singh University presents the Sant Baba Malki Singh Ji Memorial Environmentalist of the Year 2023 award to Professor Dr. Adarsh Palve for his leadership in linking science, public policy, and citizen engagement to address urgent issues of global environmental change and empowering sustainability. Thank you so much. Yes, sir, you're audible.
And rather I am honored to have a kind of gratitude and facilitation by the university. But this gives me an more encouragement to do much more for the our state, for the environment, which is required from each one of us. So when we talk of the issues, they are abundant. But I think when every individual will do own work as a my environment, my responsibility. So I think the Punjab, which is known for its environment, that would be again re-established. So with this wishes, I am very grateful and thankful to all of you that you have been doing wonderful work in academics, and the environment is the need of the hour. So it is our responsibility. So individually, when we will try to act, and we will not be become the polluters of the coming days, I think the days will be the good earth, the good land, the good water will be available to us. So thank you very much. ਸਭ ਨੂੰ ਪਿਆਰ ਭਰੀ ਸਤਿ ਸ੍ਰੀ ਅਕਾਲ ਜੀ। ਬਹੁਤ ਬਹੁਤ ਧੰਨਵਾਦ ਸਭ ਦਾ।
For your insightful message. You are really a person who is basically bridging the gap between education and the society. Thank you for your words and your kind presence. Thank you so much.
Thank you, ma'am. Now I would like to request respected Chancellor Sir Sant Baba Manmohan Singh Ji, Secretary Sir Dr. Sardar Hardaman Singh Minhas, respected Vice Chancellor Sir, society members and our Registrar Sir to please do the honors of the awardees. There were 4 categories of awards during against which the abstracts were called by the different participants. So the first award is in the senior scientist category. The Senior Scientist Award goes to Dr. Vineet, Associate Professor, Lovely Professional University, Fagwada. But I think he's not present with us. The Young Scientist Award goes to Dr. Aditya, Postdoctorate Research Fellow, Maryland. Even he could not be present amongst us, but on his behalf, I request Dr. Talib to please receive the award. Best Oral Presentation, Ipsa Gupta, Department of Botany, Punjab University, Chandigarh. Dr. Vikrant, please receive the award on her behalf. Best Poster Presentation, Meetu Bharti, Department of Physics, Barrack, Mumbai. Because she is not present, Dr. Satnam to receive the award on her behalf, please. Congratulations to all the recipients, and I thank you for your extraordinary contribution to the field of science.
Coming together is a beginning, keeping together is a progress, and working together is a success. A successful team has many hands and one mind. We have received the end of this conference. It might be the 3rd day of the conference. The entire organizing team has been working relentlessly and enthusiastically day and in, day out to make these 3 days a worthwhile experience for you all. I would like to congratulate the entire team of University Institute of Sciences for working tirelessly and energetically. You all deserve a huge applause and appreciation. I would request the Honorable Chancellor, sir, worthy Secretary, sir, worthy Vice Chancellor, sir, our respected dignitaries, Registrar, sir, Dean Academics, sir, to please honor our organizing teams with a token of appreciation. So first of all, I would request the convener, Dr. Shweta ma'am and Dr. Nisha, to please receive their awards. Now I would request co-convener Dr. Vikrant to please receive his award. Dr. Aksh Sharma and Dr. Hani Sharma. I would request Organizing Secretary Dr. Yunis to please receive his award. Now I would request Joint Organizing Secretary Dr. Mittu. Dr. Mittu, please receive your award. Dr. Inderdeep Singh. Dr. Shalu. Dr. Chetna Sharma. And Dr. Nalini to please receive their awards. Now I would request Professor Dr. Purushottam Singh Tyagi, Scientific Advisory Committee member and Award Recognition Screening Committee member, to receive his award. Dr. Anju Sood. She is not present with us today. Dr. Vikas, member Scientific Advisory Committee and Award Recognition Screening Committee. Dr. Indu Sharma, member Website Management and Media Publicity Committee. Dr. J.R. Bhalla, member of Finance Committee. Dr. Anil, member Publication and Printing Committee, Hospitality and Accommodation and Refreshment Committee. Dr. Ajit Pal, member of Technical Support Committee and Finance Committee. Dr. Vijay, member Momento Flex Designing and Printing Committee and member of Venue Management Committee. Dr. Gurpreet, member of Stage Conduct Committee, Decoration Committee and Cultural Event Management Committee. Dr. Vivek, member TADA Committee. Dr. Talib, member of Publication and Printing Committee, Certificate Committee and Refreshment Committee. Dr. Rampal, member of Poster Presentation Committee. Dr. Satnam, a member of Technical Support Committee. Dr. Akhilesh, member Website Management and Media Publicity. Dr. Jairus, member of Refreshment Committee, Venue Management Committee. Mr. Jujar, member of Refreshment Committee. Dr. Parveen, member Hospitality and Accommodation Committee and Technical Support Committee. Mr. Jatinder Singh, member of Venue Management Committee.
Mr. Rajesh, member of TADA committee. Dr. Mandeep, member of registration committee and purchase committee. Mr. Satveer Kaur, member of registration committee. Ms. Sonia, member of purchase committees and stage conduct committee. Ms. Arvinder Kaur, member of decoration committee and cultural event management committee. Mr. Avinash, member of registration committee, hospitality and accommodation committee. Any? He's not present today. Ms. Kamaldeep Kaur, member of inauguration committee. Ms. Bhavna, member of certificate committee. Dr. Amandeep Kaur, physiotherapy member of poster committee. Ms. Seema, member of decoration committee. Mr. Rajesh Rohila, member of hospitality and accommodation committee. He is not present today. Ms. Piyushi, publication printing committee and memento and flex designing committee. Dr. Aarti, poster presentation committee. Ms. Anjali, decoration committee. Ms. Mamta, stage conduct committee. Ms. Sharan Preet Kaur, inauguration and reception committee. Mr. Dilawar, refreshment committee. Ms. Neelam, decoration committee. Ms. Pamaldeep, member of poster presentation committee. Mr. Lucky Malhotra, member of TADA committee. Ms. Meena, member cultural event management and inauguration committee. Ms. Himani, member of decoration committee and inauguration committee. Ms. Renuka, member of decoration committee. Ms. Paramjeet, registration committee. We are also thankful to few of the members who were a part of the technical committee and helped and rendered their services throughout this conference. Mr. Dhami, the technical committee member. Mr. Parminder Singh. Ms. Param. And member Multimedia Center, Mr. Sukhwinder, for rendering his services. Above all, we are grateful to the Department of HMCT for rendering their services throughout the conference. And I would like to invite the HOD of the department, Mr. Roop Singh, to please receive the award on behalf of the entire department. Thank you all for being available throughout the conference and doing your part. Now I would like to request on stage convener Dr. Shweta Singh for the vote of thanks.
Very good afternoon to everyone. Thank you is such a prayer that cannot be seen or touched, but it must be felt. So it's my honor and privilege to get the opportunity to propose a vote of thanks on this special occasion. Firstly, I would like to thank Almighty God for making this event a great success. I, on behalf of the organizing committee, convey deep regard and hearty thanks to Honorable Chancellor Sant Baba Manmohan Singh Ji, Worthy Vice Chancellor Sir, Professor Dr. Dharamjit Singh Parmar Ji, and respected Secretary Sir, Sardar Hardaman Singh Ji, for providing the necessary administrative approval for organizing the event in our campus. Thank you, sir. I would like to thank all the honorable delegates who blessed us with their presence. I am also very much thankful to all invited speakers for their informative talk. My sincere gratitude to the government sponsoring agency DSP SERV and Punjab Pollution Control Board for being a pillar of financial support and guidance. I am also thankful to the registrar sir, Dr. Aneet Kumar, controller of examination, Mr. Roop Singh sir, Dean Academic, Dr. Amrinder sir, finance officer, Mr. D.V. Pathak sir and his team, especially Vandana ma'am and Rathod sir, and all dean and deputy dean of different institutes. They supported in all possible manner to organize this conference. Once again, thank you, sir. I would also like to thank Captain sir for providing the transportation facility to the delegate, participant, and faculty member. I would like to thank whole HMCT team for their hospitality. I am also thankful to Mr. Sukhvinder sir, Mr. Rajvinder Dhami sir, Mr. Parvinder, Ms. Paramjeet Kaur, and Mr. Kuljeet sir for providing technical support and their expertise in the term of designing, publicity, and technical support for smooth conduct of event in hybrid mode. Thank you, sir. I would like to thank all the participants for their presence to make the event successful. These kind of events are not organized overnight. The wheel keep rolling months prior to make such event fruitful. My heartfelt gratitude to each and every member of the organizing committee member for tireless effort toward making this conference a success. Last but not the least, I am thankful to the non-teaching staff member for making this event a successful one. We hope you have gained the valuable knowledge during these 3 days, and we look forward to seeing you again in our future event. Thank you so much, sir.
Thank you, ma'am, for your kind words. As we disperse, let us not forget that we are part of a larger community where our knowledge and expertise can make a significant difference. Let's carry forward what we learned today to make our world a better place. Have a great evening. Thank you, all of you. Can we please gather for a group photo? Oh.